All right, welcome everybody. Brian McLogan here, and what I'd like to do is go through our precalculus EOC. Sorry guys, I had a little bit of difficulty here. So what I had in store is we're in a new house. So I'm in a new studio with new internet, a new setup, and obviously also we have kids that are trying to go to sleep. So it's been kind of a crazy last 2 weeks for you, for myself, and hence that's why I haven't been going live for my students as well as for you guys. So I just wanted to kind of let you guys know about that. Now that we are kind of back into the routine, I do plan on continuing to get this over here. So there you go. I see you guys, Rubes and Sunny and Shalini. Thank you guys for joining in. And sorry for those of you guys that couldn't, but I did see there was a super chat back in the way. Oh yeah, and by the way, you guys are probably going to see here some crying because the girls have been trying to fall asleep probably for the last hour now, and they have not been able to do it. So Armen, thank you, man. I appreciate the super chat. I'm sorry, guys, for all of this stuff going on, but what we're going to do is we're going to cover the test. And again, this is for precalculus is what I'm going to be covering. And again, before I get started on this work, guys, please make sure if there's any kind of issues with the audio and everything, it's like I said, this is the first time I've done the live stream in my new studio at my new house. So I tried to get everything set up the best I could, but I'm not sure exactly how perfectly everything is, kind of coming through. So hence the reason what I did is when I first started the live stream, I noticed that the internet would immediately drop down, and it looked like everything was going good, but then it was giving me a red signal for the live stream. So I immediately just went ahead and hit the Ethernet cord because I'm going to be covering 108 questions tonight. I don't know why I'm doing 108 questions, but that's what I came up for my review. So if you are in precalculus or trigonometry or taking like an algebra 2 or a college algebra, I just kind of want to go through the topics that I'm going to be covering, and then also let you know I will be time stamping this video as well as providing this review and the answers for you guys for free. So for those of you that are not able to stay with me for the entire duration of my review because you have other things going on, other exams, perfectly fine. Make sure you guys can always come back and check this one out. All right. And I say I have a new member. Thank you very much. I look forward to getting some of these new documents and stuff that I've been working on out to my members that I have been posting for a lot of this stuff I've been creating this year. And I'm also looking forward to next year, and throughout the summer, creating more documents that I can share with the members as well as doing some private live streams. So those are some things that I'm looking into including as well for teaching next year. So before I get started here, we are going to be dealing with functions. I went through and topped everything. A whole bunch of functions. So we have, and then we're going to cover some questions in polynomials. We will get through some questions of rational functions, some questions in trigonometry. Then there's quite a bit of questions in trigonometry, and I'll go through all of them. I don't know what I'm doing to myself. And then, geez, I still got, and then we're going to hit on analytic trigonometry. And then we'll come through applications of trigonometry, doing some word problems, lovely, as well as some vectors and parametric equations. And then we will next move on to analytic geometry, also known as conic sections. Hit a couple problems on that, and then we'll end on limits. So that's what we kind of covered through this whole class. And you can see for the limits questions, guys, we will get through all 110 questions. So for my students, I did add a couple extra questions that I wanted to do for you guys on there. So all right, let's go and get to the front, guys. And again, I know some of you, unless you're my student, you don't have a copy of this. So hopefully what I will do is in the description of this video after I'm done with the live stream, I will put in the timestamps for each chapter, as well as put a link where you guys can go ahead and get a download of this as well as the answers for you guys on there. Arson said, even his old stream is up. Go check. It says last stream 6 minutes ago. I'm not sure. It should just connect with my first stream should just connect with my old stream. I don't think it should start a new one, but I'll go ahead and check. No, it looks like it's connected in with this one. So either way, if you can go ahead and connect on the live stream on there, we will get from there. All right, and one last thing is to also let you guys know about this is I will, what was I going to say? Also on this one, I'm going to plan on, I'm not going to be able to go through any questions for you guys. So just wanted to also let you guys know about that. All right, so let's go ahead and let me get through. Let me just check so I can make sure on my streaming health real quick before I get there. Just want to make sure I got, there we go. All right, perfect. So I can see this live stream now is going good, and like from the original one, it wasn't going so bad. So, all right, guys, let's go ahead. Arson, did the old stream come up? Because it's not coming up on my end. Is it connected back in with this? Because I think when it uploaded that, I'm not sure how it connected where I'm at, but I will. What I'll be able to do is I can obviously trim and work from there. But it wasn't showing up on my answers, so Well, anyway, it's not showing up on my channel yet, or at least on my analytics. So I'll go ahead and look though for those streams. Sometimes when you change the title of it, then it will pop up. So let me just get this back real quick. All right, and then also at the end of each chapter, guys, I will just take a quick little 5-minute break. And then if you guys have any questions or answers or anything else I can get with you guys, then I will go ahead and get started. So let's see here. Let me get just real quick. Just go back. All right, guys, I swear I'm just getting, everything got a little hectic here with my stream channel. Yeah, I went back to the old video manager, but it's not showing my past live stream yet as far as uploaded. So I am going to go ahead and get started with the review, and then I will come back to once everything's uploaded. So, all right, let's go ahead and get started with functions. On this, first one here, you have if f of x equals the square root of x minus 1, then the domain of f is given by the interval. All right, so the main thing we got to remember with this one is, what is our domain restrictions of a function that we have talked about, at least in this class. And in chapter 1, we talked about, well, we can't divide by 0. So we want to figure out the values that x squared minus 9 is equal to 0. And you can go ahead and solve, and x is going to equal plus or minus 3. So we know that x cannot equal plus or minus 3. And also, I do want to remind you guys, this is a EOC review, so I'm not going to be going full explanation on how to get every single answer, or also am I going to show all of my work for everything. I will try to do my best to explain what I'm doing as well as, my steps. But again, I want to also get through 108 questions before midnight tonight, so I'm not going to be spending too much time on each and every problem, just trying to get the basics to review and then move along. But however, I will, if I notice some certain things to point out that I recalled from teaching or mistakes students made, I'll make sure to try to add those. So we know x cannot equal 3 or negative 3, so I'm going to create a number line that represents all the values that could represent the domain of that function. We also see a radical, and we remember that the domain restriction for a radical is we can't take the square root of a negative number. So therefore, anything under my radicand has to be greater than or equal to 0. And then you just go ahead and solve, and you can see x also has to be greater than or equal to 0. So x cannot equal negative 3 or 3. I'm sorry, or it has to be equal to 1. That's why you got to be careful showing your work. But x has to be greater than or equal to 1. So it has greater than 1, but it can't be equal to 1. So therefore, remember that when we have a term that's defined, that's going to be contained, and this would be an open circle. So it would be 1, 3, and then union 3, infinity, which is answer C. The next one says, which of the following has no vertical asymptotes? So remember, vertical asymptotes is when the values that make the denominator equal to 0, but they cannot be divided out. So even though this expression, the x minus 7s, divide out here, we still have a vertical asymptote at x is equal to 5. All right. Now this one is non-factorable, so a lot of students will have a kind of a questionable on this. But remember, if something's non-factorable. There you go. Hopefully that's back on. Okay. But remember, if something's just non-factorable, make sure you guys got me go. Yeah, all right. Make sure you guys let me know if there's anything else didn't come back through, but it looks like everything's all right. So remember, when you are looking for x squared minus x minus 1, we don't know if that's not factorable. You can't factor it. But there still could be values that can make the denominator 0. They could just be irrational zeros. However, they can't be imaginary or complex. So what we can do is, rather than doing the whole quadratic formula, we can just check the discriminant. B squared minus 4 times 8 times C. And remember, that tells you what is under the radical in the quadratic. And if that is a positive number, therefore we know that but it's not a square number, therefore we can see we have irrational zeros. So I take negative 1 squared minus 4 times 1 times negative 1. So therefore I have 1 minus, and this would be negative 4 times 1. So that's going to be plus 4, because that turns into a positive, so that equals 5. So either way, you can see that these are going to have the square root of 5 is going to be your zeros, but these are going to have vertical asymptotes. So that is going to be, I'm not going to calculate what the vertical asymptotes are, I just know they exist. Here I have a vertical asymptote at x is equal to positive 2. And then here, I just notice if I simplify this, this would be x minus 4 times x minus 5. Well, what we notice is both of these divide out, right? And so therefore, since they both divide out, there's no asymptotes. You're just getting the function f of x equals 1, which would not have a vertical asymptote. So therefore, D is the answer here. And to be honest with you, I probably wouldn't go doing this work. I'd probably skip around to the other answers and then come back to that. So I probably should have thought about that at first. The next question says, which of the following has a hole at 1, 4? Now, this is relatable to kind of what we talked about at limits. There's a hole in the function. We could talk about a hole from a rational function as well as from a piecewise. Now, remember, if it has a hole, that means the term x minus 1 gets divided out, all right? Because that means 1 is a undefined value. And see, when 1 here makes it undefined, but it gets divided out. So there's a hole at 1. In this case, but is the whole value at 1, 4? So what we do is we take the value that's left over, the 1 over x minus 5. So basically you have like f of x, the simplified version is 1 over x minus 5. And basically what we want to do is, well, if you were to plug in 1, would you get 4? And in this case, you can do that in your head. F of 1 is equal to 1 over, negative 4. So no, that doesn't give you 4. That gives you negative 1/4. So that does not have a hole there. Here, the function is not even undefined at 1, so that's not true. Here, we have an undefined value at 1, but it doesn't get divided out, so it's an asymptote. Don't worry about that one. Here, you can see there's a hole that gets divided out. And now, if we were to plug 1 into your remaining function, this is supposed to have an f of x there. Forgot to write that in. So therefore, you're just left with 11 times 1 plus 1. Let's just write it, because we'll just do this in our head. So now when you're left over, you just plug a 1 in for the x, and you end up getting 12 over 3, which equals 4. So you can see that when you do f of 1 in this case, you end up getting 4. So f of 1 in this problem equals 4 after those divide out. This is a piecewise function, but it's not undefined at 1. So therefore, there's no hole or jump or discontinuity at 1, at least not that is explicitly known from right there. So, and therefore, these two functions are continuous. So we can definitely rule that one out as well. All right, question number 4. Give the function f which of the following represents a horizontal stretch by a factor of 3. So, one thing to just kind of remember up this when we're looking into functions, a lot of times when we're trying to remember what is the, transformation. Sometimes it's just easiest just to pick like a function and remember like what is that going to do to the function. So what I was teaching my students to use was the absolute value function. So here we have absolute value of x, which, you guys, hopefully you guys remember is the V-shaped graph, right? No, do that one. All right, so if it talks about a horizontal stretch, first of all, we can definitely knock out anything that's on the outside. And if you remember, horizontal was horizontal transformations. So anything outside the function was not a horizontal transformation. So therefore, we have these two. But if you remember, like, what is the difference between these two functions? And this is why I was getting the other color over there. Because if you have 3x, right, and just pick any number you want for x, like x is 1, x is 2, you're going to get a skinny graph, right? And you can see that's not horizontally stretching the graph, that's horizontally compressing the graph. So A is not the real answer. However, if you look at green, like 1/3, like if you picked like 3, that would be at 1. So you can see that the green one is basically your slope here, but that is horizontally compressing the graph. And so therefore, A is your answer. And the way that this is kind of written, we didn't go through the classes. We talked about horizontal stretches and compressions in terms of K. And I talked about the value of K. But another way you can look at it is if it's a horizontal stretch, then you're going to have K is X where K is positive. Or you could look at a that's a horizontal compression. A horizontal stretch where K is positive would be written like this, 1 over K times X. So it's just make sure you understand it's a fraction is going to be a horizontal stretch. All right, for the next one, it says given a function represents a vertical compression. So just like horizontal is inside, vertical is outside. Well, obviously plus, I didn't talk about it there, but plus, guys, is shifting left or right, or up or down, right? Or plus on the inside is shifting left or right. So that's not it, and that's not it, and that's not it, because those are inside. Those are horizontal stretching compressions. This is a vertical compression, and again, kind of going back up to this purple, like we understand if you're going to multiply by 3, the absolute value of 3 on the outside, that's going to be a vertical stretch. So if you want to compress it on the outside, you're going to need a fraction. It's going to need to be in this form, f of x equals 1 over k times your function, like absolute value of x or whatever your function may be. So therefore, a larger number than 1 on the outside is vertically stretching, so your fraction is going to be your compression. It's just the factor of 3 gets people confused because they think 3, but it's really 1 over 3 is a representation for that graph. All right. Given a function f, which of the following represents a horizontal shift 3 units to the right? So again, remember guys, horizontal shifting of a function is going to be inside. So all of these transformations outside of f of x are not going to be horizontal shifting. Remember, horizontal shift is plus or minus, right? When we're stretching the compressions, that's multiplication. So therefore, that's not going to be it. So we basically have these two. If you remember, a horizontal shift is in the form of f of x. You can think of f of r, let's just do x minus c. That'd be a shift to the right. So that'd be c units right. So if we want to go 3 units to the right, we need to write this as x minus 3. And again, you could look at you could practice with some functions or look at a graph, or just plug in a random function, like x minus 3, and then plug in, x plus 3, and plug that into your calculator real quick and just see which one is going in which direction. But you can see the one that's shifting to the right here is going to be your answer A. Oh, I keep on forgetting. I went through all these answers just to make sure that I have everything. So let's make sure. I'll just make sure I go through that and follow along with the answers as well. Just want to make sure because there's so many different problems. It took me like forever to go through these and work through them and show my work. So I just want to make sure that obviously I'm not making a silly mistake here and I'm going live and then making the mistake there. Let me just check that. Okay. So the next one says, if f of x equals 2 plus ln of 3x minus pi halves, then compared to the parent function, y equals ln of x. Let's graph that out. The graph f is shifted. What? Right? So the main thing is basically, we looked at this a couple different ways. I think the easiest thing I told you, when you have something very difficult like this, if you want to find where it got shifted, just set whatever's inside of your function equal to 0. Like a lot of times I talk to students about like factoring out a 3, and so forth, or, factoring out whatever the coefficient of 3 is. And that's fine. And that usually works for most problems. Students would have a tough time factoring out a 3 because they don't like dealing with the fractions. All right. But when you just solve for x, remember dividing by 3 is the same thing as multiplying by its reciprocal. So therefore you get x is equal to a positive pi over 6. So you can see that since x is started at 0, but now it's a positive pi over 6, this is going pi over 6 units to the right. So again, my easiest thing is just to pi halves divided by 6, guys. I just multiply by reciprocal on top and bottom to solve for that. But again, the easier thing is just set whatever is inside your function equal to 0 to go ahead and solve. Question number 8 says, give a function f, which of the following represents a vertical shift 4 units followed by a reflection across the x-axis. So obviously, guys, if we're vertical shifting it up 4 units, we got to add 4 on the outside. So that doesn't work, that doesn't work, that doesn't work, and that doesn't work. So the only one that's actually shifting the graph up 4 units is this one, and it's being reflected about the x-axis. So that is true. So all of them kind of look, fairly simple. Just remember, if you're shifting up, it's positive, adding positive and negative on the outside. Question number 9. If the point 3, 4 lies on the graph of an invertible function f, then which of the following points lies on the graph of its inverse? So a couple things to remember here about points and their inverse. When we talked about graphing points, that they are reflected about the y equals x line. And basically what we did was, is we flip points about this y equals x line. So if I go ahead and do that, what we notice is that that inverse point is in the first quadrant, right? So when we reflect this, it's in the first quadrant. So therefore, anything that has a negative is not going to be an answer. All right. And then if we just wanted to kind of estimate here, I'm not doing a bad job, but you can notice that it looks like this is roughly around this point 4, 3. And again, one thing we looked at in the algebraic approach is if you have a function, to find its inverse, you swap the x and the y. So if this is the x coordinate, that's the y coordinate, look what happens. The x and the y coordinates get swapped. So therefore, A is your answer here. Question number 10, the inverse of the function f of x equals 7x plus 8 will be. So therefore, remember in this one, we're just going to kind of go through the steps of finding the inverse. The first thing we usually do is just replace f of x with the y. Okay, then we swap the x and the y coordinates, or variables. And then now basically solve for y. So we subtract the 8. So we have x minus 8 equals 7y, divide by 7, divide by 7. And we could call this f inverse of x equals x minus 8 over 7. And obviously it's not called f inverse of x though. They gave it the name g of x. But again, we just want to go ahead and make sure we find our answer, which is answer letter A. All right, moving on to question number 11, which is saying f of x equals the square root of x and g of x equals x squared. Find the g of f of x. So just remember when we're doing g of f of x, guys, that represents g of x times f of x. All right, so in this case, it doesn't really make sense to go from a multiplication and then have a division problem. So I'm just going to cancel these out. These are kind of some interesting answers, but this one really kind of marks me as interesting. Like, how did it get fractions? What would it do? Well, if I have a radical, remember we can rewrite all radicals, square root of b over x to the a. We can rewrite that as x to the a over b, right? So therefore, if I want to multiply these two functions, I could basically have g of x, which is x squared, times f of x, which is going to be x to the 1/2. Now, when I multiply them, and this is very careful, don't multiply the powers, right? Make sure you add the powers. So therefore, this is going to be x to the 2 plus 1/2. And then you can just rewrite 2 as 4 over 2. Oh. plus 1 over 2, and we get x to the 5/2. All right, and I'm almost done, guys. I got 3 more questions, then I'll take a quick little break, just check with you guys in on the stream here. So x equals 5/2. All right, everything's looking good. Sweet. So therefore, that is answer C. Next one, number 12. If f of x equals the square root of x and g of x equals x squared, then g of f of x. So just remember, guys, this is basically taking one function and plugging it into the other function. So we're going to take the f of x function, which is square root of x, and plug it into the g of x function. So that is equal to square root of x squared, which is equal to x. So therefore, you guys can see that answer is D. And obviously, the square root and the squaring obviously undo each other, and therefore you get x. For question number 13, if f of x equals the square root of x and g of x equals x squared, then f of g of x. So this one's kind of the same thing, but now we're plugging in the g of x function into the f of x function. So therefore, this is going to be the square root of x squared. But again, either way, those are inverse operations. They undo each other, and that's just going to leave us with x. All right. Question number 14 here is if f of x equals x minus 7 and g of x equals the square root of 4 minus x, what is the domain of f of g? So remember, guys, this is basically just dividing, or should have written that of an x. So basically, that's just taking our f of x function, x minus 7, and dividing it by the square root of 4 minus x. All right. And so now we got to look at our domain restrictions. And remember, our domain restrictions we talked about at the beginning of this chapter. We know we can't divide by 0, and we can't take the square root of a negative number. Well, so rather than, typically we would say 4 minus x has to be greater than or equal to 0, right? But again, it can't actually equal 0 in this example, because if it equals 0, then the denominator would be equal to 0. So rather than saying the denominator can't equal 0 and the radical has to be positive, we can just make the radical just has to be positive and not equal 0 as well. And that satisfies making excluding values that make the denominator equal to 0. So now I can just go ahead and solve. So 4 has to be greater than x, or we could say x is less than 0. And then just go through a number line here, guys, and you have 0, and x has to be less than, so I'm going to use a open circle and going that way. So it would be open circle and infinity is open circle and to 0. No, this is going to 4. How did I stop at... Where'd that 0 come from? Those numbers are 4. Okay. That's 4. All right, perfect. All right, guys, last one on the functions, and then we'll take a quick little break and get it before polynomials. So the next one says, if f of x, negative 4, 0. Yep. If f of x equals x squared plus 1, then f of x. So this one's kind of interesting. This is basically, remember, just a composition of itself. So this is basically saying f of x. So you're going to take the f of x function and plug it into the f of x function. So that's going to look something like this. So you took f of x, which is x squared plus 1, and plugged it into x squared plus 1, in for the x variable. So now we just need to expand this. Now, hopefully you're good with binomial expansion to the second power. That's just going to be x to the 4th plus, let's see, that would be 2x squared plus 1, and then plus 1 right there. So now we can just combine our like terms here. So this would be x to the 4th plus 2x squared plus 2. All right. And therefore, we can see that it is going to be answer E. All right, guys, that is it for functions. I'm just going to take a quick little break here, and that was my longer one, so that took 30 minutes. Crap. But either way, we covered 15 problems here for polynomials, and then we'll get on to polynomials. So just check in. So Joseph, not in his class, but I've been needing this. Well, I'm happy, Joseph. I meant to get this over to you guys online a lot sooner, and I apologize for that. It's just obviously moving and kids and all that kind of stuff made that a little easy. So hopefully I'm still able to catch those of you that need to take an exam, and I can help you out with that. And hey, let's Yasmin, Anish, and Yoni is on. Good to see you guys. And Lamar, we're at the numerator. All right, very good. So, just a reminder, guys, I will provide some timestamps here for you guys. Yes, and this live stream will be available because this is going to be a very, very long live stream. So make sure when you check back in there, I'll make sure that I have the timestamps available for you. All right, so let's go ahead and get started on the polynomials section. So the next one says to factor completely. And so now we're just getting into polynomials factor completely. I say it has 4 terms, so immediately my thought is to factor by grouping. All right, so I group the whatever they have in common in the gov, which is an x, and that leaves me with a x squared. Now, actually, factor out an x squared. Why am I factoring out just an x? They both have an x squared in common. So if I factor out an x squared, I'm left with an x plus a 7. And then here, I can factor out a negative 7. And that leaves me with an x plus 7. And again, if you didn't factor, if it's not factor by grouping or you did something wrong, these 2 terms have to be the same because you have to factor them out again. So that's going to be x plus 7 times x squared minus 7. And again, you could factor this across irrational numbers, just a little FYI, just in case they went one more step. But in this case, they don't ask for that. They just ask for the factored form in there, which is answer B. All right, which of the following gives the complete factorization? So this one does not look very fun, right? So the first thing we want to do, though, is just kind of write it in our standard form. Like, just make sure you understand that that's in the form 3x squared plus 23x, 23x squared minus 8x. Now, the one thing I notice is I have to factor out an x, or they all share an x, so I can factor out an x. So I'll come here. And the nice thing about this, actually, guys, is if you're doing a multiple choice question with a factoring answers, like you can also work backwards, right? You don't have to, try to actually factor this. Just see which one of these would give you any close to this. Well, first of all, I know x has to be in front, so I know these 2 answers don't work. Then I know my last 2 terms need to multiply to give me negative 8, right? Well, this gives me a positive 8, so that one doesn't work. So my middle term needs to multiply to give me my last 2 terms need to multiply to give me negative 8. First 2 terms need to multiply to give me 3x, right? But then since my middle term is positive, that means my larger of my 2 products, so my 1x and my 3x times negative, or my 3x, my outer terms and my inner terms, the larger of those 2 products needs to be positive. Well, you can see here that 3x times 8 is positive 24, and then this would be a negative 1, which gives me 23. So therefore, this answer is going to be E. Okay, so I didn't even have to go through the factoring portion. Obviously, that's something you can... Minus 8. Oh, and I even wrote that. Larger product has to be positive, which is 3 times x, 3 times negative 28, that has to be 24, and that's a negative 1. Yeah. Hold on. I wrote down A for whatever answer, and I'm not sure why I wrote that one down. So let me just double check my work and shown, because I would have showed my answer. So let me just double check, because I wanted to make sure my answers I checked, but I'm not seeing any issue with that one. Yeah, but it needs to be I don't want a negative 24. I want a positive 20. Yeah, answer Z. Okay, got it. Cool. All right. 18. So 18 says the function f of x equals negative 2x times x minus 3 squared times x plus 3 cubed times x minus 6. How many relative extrema? So, again, this is a polynomial that's written as a linear factorization, right? It's a product of its zeros. These tell us our zeros as well as the multiplicity. And again, that's very important for us to understand because we can graph this polynomial. We can graph this polynomial because we know what the zeros are, we know what the multiplicity, and we can figure out what the end behavior is. But to figure out the end behavior, we need to figure out what the leading term is. And that was something that was very important in this unit, polynomials, was figuring out that first term. So if I multiply, or if I was to expand these, all right, if I was to expand these, I would get this, okay? And therefore, then if I was to multiply this all over, oops, no, that's not, that would be a squared. Okay, so if I was to multiply this, f of x equals negative 2x times x squared times x cubed times x minus 6. And by multiplying all of this out, then I want to be able to figure out what would be my highest middle, or what would be that first term. So if you were to multiply this again, remember you're just basically adding the powers here. So therefore, I would get a first term of negative 2x to the 7th. Now, I don't really know what is going to come after that, right? Because there's no need to actually multiply this out. But from here, we can identify that the graph is going to have an end behavior of rises to the left and falls to the right. Now, there are some other things we learn from understanding a polynomial that from this first term. We understand that the degree of the polynomial is equal to 7, right? So the degree is equal to 7. That means there's 7 total zeros. And that was by the fundamental theorem of algebra. Zeros. Right? There are 7 zeros, real or complex. And then the max number of extrema was 6, or would be always 1 less than the degree. But be careful, because that just says the max number. So the way to understand this problem is we actually need to graph this. So you could plug this all into your calculator from the beginning and just try to see how many curves, but I think you'd probably be playing too much time with your window. We know that there is a 0. Let's figure out where the real zeros are. The real zeros are the x-intercepts. So we have a real 0 at 0, right, at x is equal to 0, at 3, negative 3, and 6, right? You basically set each factor equal to 0 and solve. So we have 0, 1, 2, 3, negative 3, and 6. Okay, and then remember, to understand what's happening with the graph, we need to understand the multiplicity of each 0. Remember, when the power of the degree, or the power of the factor, is odd, the graph bounces. And if it is even, then if it's even, it bounces. If it's odd, it crosses. So at x plus 3, negative 3, that has an odd multiplicity, so that's going to cross. At 0, that has an odd multiplicity, so that crosses. At positive 3, that has a even multiplicity, so that's going to bounce. And then at x equals 6, that has an odd multiplicity, so it's going to cross. So therefore, the extrema, remember, is the relative max, relative min. And you can see that there is 1, 2, 3, 4. 1, 2, 3, 4. So don't fall by, even these theorem stuff is great, but that's just giving you kind of like the max number of extrema. The actual number of extrema in this example is 4. Let f be the polynomial function with integer coefficients such that f of square root of 3 is equal to 0. Which of the following statements is not necessarily true? So again, it could be true, but it's just not necessarily true. So we know that f of square root of 3 is equal to 0. Well, then that tells us that x equals the square root of 3 is going to be a 0, or also known as a root. So that was one thing that we talked about when we were, identifying something in the, by plugging it in with that with the remainder theorem. Well, obviously, if it has a remainder of 0, then obviously it evenly divides. So therefore, that is going to be a 0 or a root. Which brings us to the factor theorem, which states if f times square root of 3 is 0, then that means x minus the square root of 3 is a factor. And if x minus square root of 3 is a factor, then x equals square root of 3 is a 0 or a root. That's basically that relationship we talked about. So, oh, what am I doing? Oh. That is true. I didn't mean for that to be the answer. So that is true. This is true. We know that if x minus square root of 3 is a 0, then x plus square root of 3 has to be a 0. And then also, if you have two factors, then their product is always going to be a factor. So what is the product of x squared root of 3 times x minus the square root of 3? Well, this is difference of two squares. That's going to be x squared. Square root of 3 times negative square root of 3 is just going to be a negative 3. So therefore, that is also a factor. And therefore, this could be a factor, but we just don't have enough information to confirm. So therefore, it's not necessarily going to be a fact or true. All right, on to question 20. It says, if f of x equals 6x cubed plus 14x squared minus 25x plus 4, then how many possible distinct rational zeros does f of x have? If you recall, we did this was the p over q. So this would be the factors plus or minus of p over q. So remember, p is your constant and q is your leading coefficient. I'm going to simplify these on the fly. So you're just going to take your factors of p, which is 4, 2, and 1, over the factors of q, which is 6, 3, 2, and 1. All right? So it's basically 4 over 6, 4 over 3, 4 over 2, 4 over 1, 2 over 6, 2 over 3, 2 over 2, 2 over 1, 1 over 6, 1 over 3, 1 over 2, 1 over 1. But I'm going to simplify them as you go because you don't need to repeat ones that, or you don't need to, list ones that repeat. So 4 over 6 is going to be, and again, this is plus or minus for all of these, right? So it's the positive version and the negative version. So we have plus or minus 4 over 6, which is 2/3. We have 4 over 3. We have 4 over 2, which reduces to 2. And we have 4 over 1, which reduces to 1. Now I'm going to go with the next numerator, which is 2. So 2 over 6, which is 1/3. 2 over 3, which is a repeat, so I'm not going to do it. 2 over 2, which is a 1, which is a repeat, and then 2 over 1, which is also a repeat. So then I'll move over to the 1. So I have 1 over 6. Oops. So I have 1 over 6, 1 over 3, which is a repeat, 1/2, and that's it. So let's count all of them. 1, 2, 3, 4, 5, 6, 7. I am missing one. Which one did I miss? Dang it. Because I know the answer. I remember the answer to being 16. 1, 2, 3, 4, 5, 6, 7. Okay, so that's 2/3, 4/3, 2. Oh, I forgot to write 4. I did 4 over 1, but I forgot to write it. Maybe I thought it was like 2 or something. Oh, I wrote it as a 4. I see. I wrote it as a 1. But 4 over 1 is 4. And then that's 1/3. That's 2/3. That's 2/3 repeat. And that's 2 over 2, which is 1, and then that was the 1/2. So let's add that in there. There you go. So there's that, and then there's plus or minus. So since there are 8 of them, that means there's a total of 16. All right, next one. Question 21 says, let f of x equal x plus 2 times x squared plus x minus 1 minus 3. Which of the following statements is not true? So the remainder... Okay, so please note that this is not multiplied out, right? And we really don't want to multiply this out. So let's try to avoid actually multiplying this out if we can, or at least get into there. So the first one says the remainder of fx is divided by x plus 2 is negative 3. Well, we could go ahead and divide this in there, but again, we could also just check f of negative 2, right? That's the remainder theorem. When you plug in that negative 2, like if you're going to get negative 3, then that's going to represent the remainder theorem. Now, hopefully you recognize that that gives you, if you plug negative 3 in, that's going to be negative 1. And this is going to be a 9. So plug in negative 3 here, that's going to be a 9. That'd be a 6, 5, minus 3. All right, so which question is this? 21. Or did I just multiply that out? I think I did just multiply that out, so that gives me the -3, because why is that not working? Oh, that gives you 0. I'm an idiot. Jeez. All right, I'm starting to get tired. All right, when you plug in -2, obviously right here, you get 0, right? So 0 times anything is just going to be 0, and therefore you're left with -2. So is not true. So that statement is true. The next one, the remainder when fx is divided by x minus 2 is -3. So again, this one, let's plug in f of 2. So when we plug f of 2, we get 2 plus 2. And then this one, I'll just do 2 squared plus 2 minus 1 minus 3. All right, so 2 plus 2 is 4. And then we have 2 squared, which is 4, plus 2, which is 6, minus 1, which is 5, and then minus 3. So that's 20 minus 7, that's 17. Okay, so that doesn't even look close. So that one looks false. Let's just double check the rest of them to make sure they're true. The remainder when fx is divided by x squared plus x minus 1 is -3. I guess I want to check there. When x plus 2 is not a factor, well, obviously x plus 2, since there's a remainder, that's not a factor, so that's true because that's not a factor. And fx is not evenly divisible by that, so that's true. So I guess the only thing else I could do is check my C to do my denominator and division, and I actually did check it. Did I check it? Yeah, I actually did check to make sure that it is divisible, so therefore you guys would not have to. But basically, I think on a test, you notice this, you check your work here. This is obviously false, so therefore I would just say that is your false statement and then just go without showing your work. If you have enough time at the end of the test and you want to come back and just check that, then go through it. But that's not going to be something that's evenly. You're going to have to go through long division to check that one for -3. But since this one is obviously false, I would just run with that answer. For next one on question 22, which of the following statements is not true? So it says the remainder when f of x is divided by x squared plus 1 is 3. So, all right, so again, we're going to have to check that one. So let's kind of come back to that. Let's do, well, this one, B and C are about the same, right? Because when it's divided by x minus 2 is the same thing as checking f of 2. So let's figure out what f of 2 is. And that would be, well, obviously it's going to be 4 plus 1 times 0 plus 7. So that works, and that works. F of 0, let's see if that's 5. So that'd be 0 squared plus 1 times 0 minus 2 plus 7. So that's going to be 1 times -2. -2 plus 5 is going to be, -2 plus 7 is going to be 5. So that works. And then this one, f does not have a real root. Well, this one is, if you notice, this is a odd function. Like if you were to multiply this all out, f of x, you're going to get x cubed something is your highest term, right? So that times that is going to give you x cubed times that. And obviously, if you know if it's a x cubed, it follows this end behavior, false to left and false to right. So at some point, it has to cross, it has to cross the x-axis somehow, right? Only if it's even, only when the degree is even, is there a possibility where there could be no real roots. So since it is odd, there has to be a real root. So f does not have a real root. F does not have a real root. Wait a minute. F does not have... No, that is not true. That is... Now I'm like losing my brain. And I checked for the F does not. That is, which of the statements is not true? That is not true, because F does have a real root. And then, so did I do my long division wrong then? Because I thought I checked this answer for number 22. Huh. Maybe I did. Or maybe it was on that one that I was doing my math. Equals x squared plus 2. Was that it? Oh, I think it was on this one I checked this was the one I checked with long division. And yeah, it gives me -3 instead of +3. So f does have a real root, so therefore this one is the one that is false. Okay? So I'll just say it must have a real root. All right. Let's go ahead and continue on. So question number 23. Just check it out. Benjamin says, Brian, what do you suggest to study most for a pre-calc exam? Well, my pre-calculus final, which by the time I get through all of these examples, I will have available for you, which is 108 questions. So I'm almost done. I only got 3 more for polynomials, guys, and then I will check in with you guys on the live stream. So again, I'm going through a pre-calculus final, 108 examples, and we are not even close to being all the way through. So back to it. The next one says a degree 3 polynomial with integer coefficients with roots 1 and x equals 4 minus 2 square root of 3 that passes through the point -1, -52 has a y-intercept of what? All right, so we know to find the y-intercept. A couple things. To find the y-intercept, x has to equal 0, or we could graph it. But the problem to graph it is we still got to have an equation. So if we know we have the roots, that means we can write the roots as factors, like x minus 1. And then we can write x minus 4 plus 2 radical 3 times x minus 4 minus 2 radical 3. So if you remember, these are what we call the factors. So if you're given the roots or the zeros, you can always write the factors. Now, you can multiply this using multiple different ways that we have learned and from Algebra 2 or in my class. And one thing that we want to do is x minus 4. I can rewrite this. I can square these. So I can group this plus 2 radical 3. So all I'm doing here is I'm just grouping. Since I noticed that the x minus 4s are the same, since you notice these are the same, what we basically have here is the difference of 2 squares. It's really a minus b and a plus b. Now, it doesn't look like the difference of 2 squares, but you can actually just multiply them as the difference of 2 squares, because they're just do these 2 expressions. 2 radical 3 times -2 radical 3 is going to be a -12. I can expand out x minus 4. That's going to give me an x squared minus 8x plus 16 minus 12. That's going to give me a 4. X minus 1 times x squared minus 8x plus 4. Okay. But now we still need to multiply this out, right? This is all still supposed to give us our f of x function, which is like crazy. A lot of multiplying here. So let's go ahead and multiply this. Now let's do the next one using the box method. So the box method was one that you could have done for if you didn't like doing that little technique I did, then you could have done a box with 3 rows and 3 columns to multiply that as well. And that works just fine. I like using the box method just to organize things. You could also just apply to the distributive property, multiplying every term by every term here. But when I do this, I get x cubed, -8x squared, 4x, -x squared, +8x, and -4. And what's just nice about this is just it keeps like terms on the diagonal as long as you write them in standard form. So therefore, I get a function, f of x, which equals x cubed minus 9x squared plus 12x minus 4. Well, if the y-intercept is x equals 0, then I can see the x-intercept is -4. And that looks like 4, but it's positive, not negative. So to be able to figure out how to get this one, what I'm going to need to do here is I need to kind of understand what happens with transformations of functions. So if I have a polynomial, obviously, guys, if I shift that polynomial up, down, or left or to the right, that's going to change the intercepts. However, if I stretch or compress the graph, that's actually not changing the intercepts or the zeros of the function. Like, for instance, if we were doing the zero product property and I said x plus 3, equals 0. Well, if I put some random number k there, that doesn't change the zeros. x equals -3 is still the 0. It doesn't matter what k is. So what's important about that, and the whole purpose of this, is that you can multiply all of these values by a scalar. And let's just call that scalar k. Like if you were to set these, like here are your zeros, right? So you could set them equal to 0 and solve. But the first step you do is divide out the k on both sides. So the scalar k isn't impacting the zeros, but it does impact what the equation of our function is. Okay? Because now we have the scalar k. Now we don't know what k is. However, one thing they did give us is what is 1 comma -52. So what we can do now is plug in a -52 equals k times -1 cubed minus 9 times -1 squared plus 12 times -1 minus 4. And then when you go ahead and do the math there, you should get, let's see, that's going to be a -1. That's a positive 1, so -9. So that's going to be a -10, -22, -26. Okay, and then divide by -26. I'm not going to show that. And you get k is equal to 2. Now, if k is equal to 2, right, of our original polynomial, if you distribute that 2 to each one of those terms, you notice that the last term, that constant, is going to turn into a -8, which is answer A. All right, use the binomial expansion to expand. Now, again, one thing I notice here in the binomial expansion, nobody likes fractions, right? And this is to the 4th power, and we should recognize that the using Pascal's triangle here to create them, adding up those terms to get to there is going to be your coefficients. And when the second term is 4, that's going to be the coefficients for that term. However, one thing I notice here is I notice that the first term is all different. Oops, I don't want to confuse you. The first term is all different. So why don't we just find the first term in the expansion? So remember, in the binomial expansion, the first term is always raised to the first power, the highest power or the degree of your polynomial, of your expansion, of your binomial. And then your second term is raised to 0. And then obviously we're not going to go through the whole thing, but the first term goes in descending powers and your second term goes in ascending powers. And then obviously the first term of any binomial expansion has a constant of 1. So basically anything to the 0 power is just 1. So I'm just left with x to the 4th over 2 to the 4th. Well, 2 to the 4th is going to be 16, so that can be written as 1/16 over x to the 4th. Well, there's only one binomial expansion that has 1/16 x to the 4th as its first term, and that is going to be answer C. Now, for question number 25, I do need to make sure that I am a little bit more versed with my binomial expansion, because now they're asking for the coefficient of the third term. Now, I don't need to figure out the whole term, but we might as well just practice this, right? So remember, for binomial, let's do by the Pascal's triangle, 2, 1. But let's go to the expansion of 5. Okay, so for the expansion of so expansion of 5, remember these are the coefficients, and the third term inside the expansion of 5 is going to be a 10. So 10 is going to be what's going to be multiplied by your third term. So remember, the first term in a binomial expansion is raised to the power of your binomial. The second term is raised to 0. And then you have your coefficient of 1, which is from Pascal's triangle. Then we do the second term, which is going to start with your multiplier from Pascal's triangle, which is a 5. And then your first term is now going in descending term, so that's going to be at 4. And your second term is y to the 1. And then we go to the next term, so let's actually bring those up. That goes from there. That's there. And then here it's going to be 10 times 2x cubed times y squared. Now again, we're not looking for all the rest of the stuff. We're just looking for what is going to be, that term. Well, 2x cubed, let's simplify this. 2x cubed ends up being 8x cubed. So that becomes 10 because 2x cubed is 2x times 2x times 2x. So that's going to be 8x cubed. Oops. y squared. Let's just see if I can delete that. Dang it. Oh, I guess I got to multiply that. Yeah, there we go. And then 10 times 8 is going to be 80. So you guys can see the answer is D. All right, so before I get into rational functions, I just want to kind of check in with you guys. See you out there, see if you guys have any questions. Take your own to me. Asked if I posted it. Thanks. I can't see it. It's not coming up on anything on my end. For you guys, I don't know why. Thanks, Paul. Unfortunately, I'm not able to get into the class or into it, but final next month. You study most for pre-calc. Very happy to help you, Menges, and the Mar and hard-boiled salmon. Very good. Happy to be able to help you guys out here. So let's. Actually, I got an idea. Let me just take a quick little break. So we are in the middle of our 108 pre-calculus final exam review. So we're on to rational functions, which is now entering in quarter 2. And I'll be getting through these problems, guys, and be going, and I'm going to keep on going till I finish. So hopefully you guys are enjoying that. And again, if you guys have any questions, feel free to add them in the chat. I, unfortunately, for the sake of time, though, am not going to be able to get into a lot of the, I'm not going to be able to get to a lot of questions, but I will try to do my best to see if there's any questions on the previous stuff that I had posted. So, okay, let me see. Let me just take a quick little break. Oh my God, of course. You want to show this. And also just a reminder for those of you that are checking in and you are looking for like a certain topic or chapter in the pre-calculus, I will have everything. I will go ahead and make sure to put some timestamps in on everything for you guys. So therefore you guys can see exactly what it is that I am. So therefore you guys can see you know, where certain parts of each of my videos have been. So you guys can check in on the certain topics, I guess, that what I meant to say for you guys. There we go. There we go. Hold on a second. All right. All right. I finally found my old one that I was trying to get into. There we go. Nope. All right, Paul. Hopefully go ahead and check that. Let me know. Make sure that works. I don't know why it wasn't showing up on my thing, but it passed through on there, so hopefully that works. If you wouldn't mind commenting for me, Paul, as far as the last one, making sure that it all works out. But there you go. All right, so let's go ahead and check on. I think I got what I needed to get done. So let's go ahead and finish on rational functions, and then I'll go and check back on that. So rational functions, let f of x equal -2 to the x. Now again, be careful with this little negative here, right? So what I would basically do is just plug that negative into the top, because it can go to the top or it can go to the bottom. All right. For what values of x does the graph f of x have a vertical asymptote? So let's go ahead and take a look here, guys. For what values of x does the graph of f of x have a vertical asymptote? All right, so remember, a vertical asymptote is values that make the denominator equal to 0 that cannot be divided out. And Paul, again, I'm looking for you to confirm. So make sure you go ahead and check back, Paul, if you're in here, to go ahead and confirm that I got that, what I need to get taken care of. So we have -2x divided by x squared plus 3x, and Therefore, I factor out the x, so I'm left with a negative 2. Factor out the x, and I get a x squared plus 3. So therefore, that's not an x squared, that is an x. Okay, there you go. So therefore, there is a hole at x equals 0, and there is a vertical asymptote at x equals negative 3. Because again, the value negative 3 is what makes the denominator equal to 0. So for what values of x does the graph have a vertical asymptote? So it does not have a vertical asymptote at 0, guys. That is where a hole exists. So we're going to want to take that down, take that. That would be possible, but 3 does not make the denominator undefined. That's negative 3, right? So that doesn't work. That doesn't work. You can see my answer is D. And I should move, getting those up. All right, question number 27. Again, this negative is in front. Be careful. We can go ahead and put this up front. So we have negative 2x squared all over the x squared plus 3x minus 4. All right, which of the following is an equation of a asymptote? So let's go ahead and factor the denominator here. So 2, what's happening with my 2's? So this becomes a negative 2x squared. And therefore, this can be factored into an x plus 4 times x minus 1. All right. And therefore, we can say that there are vertical asymptotes at x equals a negative 4 and x equals a positive 1. Well, I see that. Now, let's look at the horizontal asymptote, because the horizontal asymptote is going to be, since the powers degrees are the same, then the horizontal asymptote would be y equals leading coefficient over leading coefficient, which is negative 2. So that's x equals negative 2, not y equals negative 2. So that doesn't work. And it's supposed to be x equals negative 4. That's y equals negative 4. So this one's a tricky one, but you can see x equals 1 is right there. All right, let f of x equal x squared plus x plus 5. Which of the following statements is true about the graph of f? So there is no vertical asymptote. That is not true. That is false, because obviously there is a vertical asymptote at x equals negative 5. There is a horizontal asymptote, but no vertical asymptote. So there is a vertical asymptote, guys. So not that one. There is a slant asymptote, but no vertical. No, there's a vertical asymptote. There is a vertical asymptote and a slant asymptote, and there's a vertical asymptote and a horizontal asymptote. So now we got to understand horizontal asymptotes. So again, remember, when the degree in the numerator is larger than the degree in the denominator, there is no horizontal asymptote. There's either a slant asymptote or a hole. Well, this one does not include a hole, so therefore it's going to be a slant asymptote. So the answer is D. D, vertical asymptote and slant asymptote. All right, now let's get on to some complex fractions. And when we did these in my class, these are some of the problems that my students were like, do these problems, because these ones look like they stink. So that's what we did. So again, the main thing I think when complex fractions, guys, to get rid of the denominators is find the common denominator. So we have 5 times x plus 6. That is your common denominator. So just multiply everything by the common denominator. 5 times x plus 6. 5 times x plus 6. And what you guys will notice is when this happens, the 5's divide out, the x plus 6's divide out. And therefore, we're going to be left with a x times x plus 6 over a 20, right? And therefore, you can see that answer is C. Just double check. Yes. The next one, the LCD, the common denominator here. It's like here, these don't have denominators, so we can put them on 1. But here, the LCD is going to be a 9x. LCD equals 9x. Sorry, I'm not sure if it's late or whatever else, but my numbers are getting bad. So that's 9x. So let's multiply everything times a 9x. 9x. So when I multiply everything times a 9x, I get a 9x squared. Now, let's see here, the x's divide out, and here the 9's will divide out. So that's going to be a, so when you multiply everything times the 9x squared plus, let's see, that's going to be an 81. All over 9x, that'd be a 9x squared, and then plus a x squared. So simplify that, becomes a 9x squared plus 81 all over a 10x squared. Okay, so therefore you can see that that is again answer letter C. The next one says simplify a complex fraction. Fat win XXX. What are you guys doing here? You guys are going crazy. I just see like my chat like out of the corner of my eye going like crazy, but this man's been doing the math for like 10 years consistently. Yes, thank you very much, X. I appreciate the thumbs up. Yes, hey Trey. I'm just seeing all these Asians going up there. I'm like, what is going on here, guys? All right. Thank you very much. That win, I appreciate it. I failed to paste. So now let's go and get into the next complex fraction here. So LCD in this one is going to be a product of my two denominators, which is x minus 1 times x plus 5. And so therefore, I don't need to multiply them out. I'm just going to multiply everything times x minus 1 times x plus 5. All right? Everything. Every single expression. Here. Here. There. There. And notice just the denominators are just going to divide out in each one. Here, this denominator divides out. Here, that denominator divides out. That one and that one. And therefore, you're just going to be left with, let's see, x times x plus 5 plus 3 times x minus 1. And then over here, you're going to have 5 times x minus 1 minus an x times x plus 5. Okay, so obviously none of our answers here are in that form, so therefore we need to simplify. But the main thing I want you to kind of cover for these last three problems is, you know, multiplying by the LCD. Each and every one, I found the LCD, and I just multiplied every single term by that LCD. And I guess I don't know why I multiplied by the LCD on the top and bottom, but I didn't show it on this one. So there you go. I'll show it that way. Therefore, I don't want you guys to overly get confused here. All right, so let's go and simplify this. Let's apply distributive property. So we have an x squared plus 5x plus a 3x minus 3. And therefore, that gives me a x squared plus 8x minus 3. So those two answers. And then in the denominator, I get a 5x minus 5 minus an x squared minus 5x. All right, so let's simplify this one last time. So I get x squared plus 8x minus 3 all over a negative x squared. Let's just finish it, minus 5, which you can see is answer D. There it is. All right, so let's go and take a quick little break, guys, before we get on to the trigonometry unit. So that was basically like Algebra 2 plus that we kind of covered. And so we basically covered the Algebra 2 kind of plus version of that, and then we got into the trigonometry. If you are just joining in on the live stream, then I just want to let you guys know that I am going through, after I post this live stream, I will make sure I have things timestamped. So I'm working through 8 different chapters: functions, rational functions, polynomials, rational functions, trigonometry, analytic trigonometry, applications of trigonometry, conic sections, and limits. So we'll be going through all of that stuff for you guys to kind of touch base on each of these, you know, kind of word problems. And from each there, every single time we have one, Fat Finn says, I want free stuff. I don't have any free stuff. I got free answers, but that's about as much as I can do for you. Trig, well, that's awesome. So we're going to do a whole bunch of some trig problems just to kind of review some of the main important parts for you guys that, you know, I think is important for you guys to be able to understand and get used to. So let's go ahead and get started on this. I just want to check on, I don't know why. There we go. Sweet. All right. It's kind of weird why it's not showing. Oh, you know what I should? I wonder if that'll do it. Sorry, I'm just trying to check on one more thing. And it's also good for me to take a mental break. Oh, that would have been... There we go. Sweet. All right, cool. So let's go ahead and get into trigonometry. And then again, guys, if you have to do some questions, I will take a break after trigonometry before I get into the sound tool. So Brandon, Rabid, Fetwin, I see you guys. Thank you. I appreciate you joining in. So let's get on to what is the radian measure of an angle in x degrees. So if something's in x degrees, then we can write it like this. X degrees. Now, again, if I want to change this to radian measure, remember our ratio, a conversion ratio to go from degrees to radians. Well, we got to get rid of the degree symbol. So we're going to want to multiply by pi over 180 degrees. That will have the degree symbols divide out. So therefore, we're just left with x times pi over 180. And x times pi over 180. And therefore, you can see that's answer C. Doesn't really matter the orientation there. Next one, express in radian measure 235. So again, if we got to convert a degree into radian measure, so we're going to take 235 times pi over 180. Now, the only really thing I know here, and again, I have calculator. I'm a lot of calculator here, which I haven't really checked yet. But the only thing I know that would be divisible into both of those, which is kind of obvious to me, which would be 5. So I went ahead and divided 235 divided by 5, like I just reduced them. So I divided by a 5 on the top and the bottom. And I got a 47 pi over 180, that'd be 36. So therefore, you can see that obviously I can't reduce that any further. I know that 5 is divisible into both of those. You know, I used my calculator to check that out, but you guys can see the answer is C. So just basically remember using the same conversion ratio as we did in the last problem. However, this one you just go ahead and simplify it, simplify the fraction. Which of the following angles is coterminal? So remember, coterminal angles are angles that have the same initial and terminal side. So if we have an angle here like this, and well, something is coterminal if it has the same initial and terminal side. So you can have positive coterminal angles. You could have negative coterminal angles. So this main thing is to add and subtract 2 pi. So we got to think in terms of fifths, what is 2 pi? Well, that would be like 10 pi over 5. So let's just kind of do this in our head. If I add 2 pi to this, 10 pi over 5, that's going to give me 24 pi over 5. Nope. And if I add again, that's 34, 44, 54. So adding is not going to give me my answer. And anyways, these don't have denominators of 5. So let's go ahead and subtract. So if I subtract 10 pi over 5, that gives me a positive 4 pi over 5, which is not an answer. But then I can subtract, because you can go around like once, and then you can go around again, as long as you keep on going in that same direction. So let's add a 10 or subtract a 10 pi over 5 again, and this time I get a negative 6 pi over 5, which doesn't work. But if you subtract a 10 pi over 5 one more time, you get a negative 16 pi over 5. Number 35, find the reference angle. So remember, the reference angle is the acute angle between the terminal side and the x-axis. So if I had an angle like over here, and I said that's my angle, then the reference angle is always positive, and it's between the x-axis and the terminal side. So you could either, there's a lot of different ways to calculate it depending on which quadrant it's in. So, however, you recognize that this angle is much larger than 2 pi. So what I'm going to want to do is reduce the revolutions that's going on. So remember, 2 pi in this terms of this angle is 18 pi over 9, right? So if I subtract, or you can just think about like how many times was, well, let's go into 9, 18, that'd be 36. So if I subtract 18 pi over 9, I'd get a 14 pi over 9, right? So let's think about where 14 pi over 9 is going to be. So halfway around a circle is pi. Well, in terms of ninths, that would be 9 pi over 9. So 14 pi over 9 is going to be an extra 5 pi over 9 away. Right? That is going to be 5 pi over 9 away. Well, obviously, it's going to be closer, like this side is closer to here than it is 14 pi over 9 is closer to 9 pi over 4 than it is going to be to 18 pi over 4. So, or let me think about that. 5 pi over 4. What was that answer? That was a 2. Hold on, let me check, because I actually changed this, and I think I might have made, that was a 6. I changed it to a 5. Let's see what I had here. So if this is, so let's do 9 pi over 4, that's 18 pi over 4. Right? Okay. So if that's going to be 18 pi over 4, then we have 9 pi over 9 minus 18 pi, so that's going to be a revolution. So now we're at 14 pi. So 14 pi is, find the revolution. Now it's like doing so many problems. Now my brain is already starting to hurt. I'm only 35 questions in. I still got to go all the way up to 108. So that's going to be 4. All right, there you go. Jeez. So that's not going to be the closest. I actually made a mistake when I was doing my work. So you got to think, like, this is kind of confusing because it's an odd number here. But if that's 18 pi over 4, so if we go an extra 5 pi over 4, right? Or, I'm sorry, we're at 14 pi over 4. Then from here to here is 4 pi over 9. And then from here to here is 5 pi over 9. Well, obviously, remember, it has to be acute. So, if we're going from here to here, it's going to be larger than pi halves or 90 degrees. So that's not going to be acute. So my acute angle here is going to be 4 pi over 9, which is answer B. And I don't think I originally got that one, but I just figured that out on the live stream. So kudos for me to check in making my answer, because I think I made the mistake here on that first one. And I did the 5 pi over 9. I wasn't paying attention. Number 36, which of the following trig functions is undefined? So remember, this is just kind of goes back to, you guys, your unit circle. All right, knowing the values that are represented there on the unit circle. So in this one, I have sine of 30 degrees. So again, sine and cosine, guys, are never undefined. So I don't need to worry about those. They're only undefined is when you're dividing by 0. So tangent of 0, that coordinate here, let's just write down the coordinate points here. That's going to be 1, 0. Well, remember, tangent is y over x. So that one's good. Cosecant of 90 degrees. So let's go to 90 degrees here. That coordinate point is 0, 1. But remember, cosecant is 1 over y. So that one's good. So I have a good idea that secant is 3/2, which is all the way going to be down here, which is going to be at a 0, -1. And remember, secant, though, is 1 over x, which is going to be undefined, since my x coordinate in this case is 0. So therefore, E is going to be my undefined answer. If theta is the smallest angle in a 3, 4, 5 right triangle, then sine of theta equals. So let's go ahead and get this triangle. So we have a 3, 4, 5 triangle. So let's do 3, 4, and 5. All right. And if the smallest triangle, then we know that, I don't know why I put a theta there. Our smallest angle is going to have the smallest opposing side, right? So our smallest angle, jeez, what's wrong with me? So there's 3. So our smallest angle is going to be opposing from 3. So there's our theta. So now if we want to find the sine of theta from this triangle, then we just say the sine of theta is going to be opposite over So from this triangle, and that's where my theta is, which is going to be my smallest angle because it's the opposite of the small side. So remember, sine is opposite over hypotenuse. So that'd be 3/5, which is A. Which of the following trig ratios could not be pi? So therefore, you could not evaluate for the tangent of pi. And again, remember pi is over here, which is the coordinate point -1, 0. So we could do the tangent of pi. Well, remember tangent, that is the y over the x coordinate. So that one works. That's y over x. Cosine is just the x coordinate, which is perfectly fine. Cotangent, which is kind of interesting. So if you think about this, cotangent, which we learn later, obviously in the chapter on identities, we learn this is tangent. So we already know that it's good. But if we were just to go from here, we would say cotangent is going to be, that's going to be the x over the y. But really, if you flip this around, then you get 0 over -1, which we know is just going to be 0, which is perfectly fine, which could be defined. Secant is going to be 1 over x, which is 1 over -1, which is fine. Let me just do this 0 over -1. Cosecant, though, is 1 over y, which is 1 over 0, which obviously we can see, guys, is going to be undefined in that regard. So therefore, that one, E is going to be our answer for our undefined value. All right, question number 39. 39 is if sine of theta equals 0.4, then sine of, you know what, I'm just going to add these. No, that one's good. But this one should be an analytic. Analytic. All right, so I'm going to add that one to the analytic just so I can put that on the analytic side. So this one says if sine of theta equals 0.4, then sine of negative theta plus cosecant of theta equals. So a couple things to remember here. Remember from your identities that the sine of negative theta is equal to the sine of theta, and that the cosecant of theta is equal to 1 over the sine of theta. So if they say sine of theta equals 0.4, then the negative sine of theta is just going to be a negative 0.4. So I'm just going to have a negative 0.4 plus a 1 over 0.4. Now, in this case, I can just go ahead and use my calculator to go ahead and get 2.1. And if you can't use your calculator, you could reduce them to fractions. Just remember, guys, that this is, 0.4 is the same thing as 4/10, and then plus over 1 over 4/10, and then just kind of simplify using fraction operations, which wasn't as much as fun, but I did do it just to make sure that I could show you guys if I had time. But I do not want to be spending too much time going over that kind of stuff because we're already an hour in and we are not even halfway through yet. So that is what you can do. Just obviously utilize the calculator. All right, so for the next one, it says if cosine of theta equals 0.4, then the cosine of theta plus pi is equal to. So this one's kind of interesting because, again, this is an analytic. Got to make sure I add those to the analytic side. So if cosine of theta equals 0.4, now what we notice here is the sum formula. So we could use the cosine of theta, and then that would be cosine of theta, cosine of pi, minus the sine of theta times the sine of pi. So this is actually in the next chapter, Analytic Trigonometry, just like that one, but I forgot, I guess I made a mistake moving them, so I'm just going to do them now. So this is the sum formula of the cosine function, and we don't know what the cosine of theta is, but we do know that the cosine of theta is 0.4. And then cosine of pi is -1. And sine of theta, we don't know what that is, but we know sine of pi is going to be 0. So that's going to be sine of theta times 0. So therefore, we just get an answer of a negative 0.4, which I haven't been checking my answer or following through, so I guess I'll just switch that up. But that should be a negative 0.4, which I didn't circle my answer, but I'm going to grow and assume that I got that one all good. All right. Moving in on to the next one, which is if secant of theta equals -13 over 5 and tangent of theta is greater than 0, then the sine of theta equals. So this one's kind of interesting. You know, what we want to do, looking at this problem, guys, is we got to create a triangle. So we have secant, and we remember that secant is hypotenuse over adjacent. All right, but we have a restriction. Tangent has to be positive, and we know tangent is only positive in the first and the fourth quadrant. Well, since I have something negative, I know the first quadrant's not going to work, so it has to be in this quadrant. Remember, my theta is always going to be my central angle. My hypotenuse is always positive, so therefore my adjacent side has to be negative, which makes sense, right? It makes sense that 5 is negative going to the left, not going to the right. I recognize that this is a Pythagorean triple, and I also notice that 12 is the only other number I have here, but it's a negative 12. So now it's saying from this triangle, figure out what the sine is. Well, sine, remember, is opposite over hypotenuse, so that's going to be a negative 12 over 13, which is answer A. Next question, 42. It says evaluate the cosine of 57 pi over 4. So we can evaluate that using the unit circle, but you recognize this has a lot of revolutions, right? Because 2 pi, a revolution around the circle, is equal to 8 pi over 4. So how many 8 pi over 4s can be rewritten in that, right? So you could write it out as like 8 pi over 4 plus 8 pi over 4 plus 8 pi over 4, right? Or you could just say like, we could also say that 8, you know, I'm thinking 8 times, what was it, 8 times 7 is 56, right? 8 times 6 is 48, and 8 times 7 is 56. So 56 is that many revolutions, right? So, I mean, if you're just going around revolution, 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 well, then we don't really need to, like, 56 pi over 4, like, that is just, you're starting back at 0. Right? If you do 56 pi over 4 over and over and over, you eventually, once you get done with that, you're back to where you originally started. So this is really equivalent to just pi over 4. And the cosine of pi over 4 is just square root of 2 over 2, which is answer A. The next one says, a solenoid with an amplitude of 4 has a minimum value of 5 and a maximum value of, so this is important. So the amplitude, remember guys, is the half distance from the max to the min. Half distance from the max to the min. So that means, you know, if we have a graph that have an amplitude of 4, that means it goes up 4 and down 4. Back to from the the middle is going to go up 4 and down 4. So it has a minimum value of 5. So I don't know what this graph looks like, but let's say here's 5. And let's say here's the graph. So if it has, oh, I'm sorry, the minimum value is 5. Redo. I guess I can go up there. Okay, so it looks something like that, right? Doesn't matter, sine or cosine. Minimum value is 5. Now the amplitude, right, is 4. So that means it goes up 4, but that doesn't, like when you go up 4, that doesn't take you to like the max. That just takes you to the middle of the graph, right? And then you need to go up 4 more units to get to this maximum value. So 5 plus 4 is 9, plus 4 is 13. And again, just to like confirm that, like look at the sine graph, right? Sine graph has an amplitude of 1, but it goes up to 1 and goes down to negative 1. Right? The minimum is negative 1. When you go up 1, you get to 0, not to the maximum value. So there's a example using the sine of x function, how this answer would make sense. The next one says the period of the function f of x equals 210 sine of 420x plus 840. You just want to find the period. So again, the period of sine is 2 pi divided by b. So in this case, we have 2 pi divided by 420. Well, 2 over 420 can reduce to pi over 210. Now you can see that's answer C. All right, guys, I'm going to be taking a quick little break here. Not yet, but I guess I have a lot more questions to go. Did I get into Analytic, or did I forget to write in where Analytic came from? I guess I just didn't put those in there. I should have moved those over. My bad. All right. Where are we? All right, so determine, I guess we'll just keep on going a little bit longer then. determine the period of 8 plus 6 cosine of 2 pi x divided by 15. So don't really get worried about the 8. You know, the 8 can be written over there, guys. I mean, but again, that doesn't really matter because the period of cosine is, again, 2 pi divided by b, right? So we're only concerned about what is being multiplied by x, which is 2 pi over 15, which looks really crazy here. 2 pi divided by 15. But again, the way that I like kind of write it is just multiply then, guys, by your reciprocal. Think of that as over 1, so those are going to divide out, so you'll just be left with a 15, which is answer C. Boom. All right, so don't get worried about where the 8 is, you know, outside, but again, period, 2 pi divided by b for sine and cosine. All right, next one is determine the range of the function. So let's actually write this one in the other standard format to get a better idea here. So we have f of x equals negative 2 sine of 3x plus 4. All right, so the negative is a reflection about the x-axis, doesn't affect the range. The 3 is a horizontal compression, which is not affecting the range. The only thing that's going to affect the range is our amplitude. So we can say the amplitude, remember, is the absolute value of a, so that's going to be 2. Absolute value of negative 2 is 2. And then we have up 4 units, so shifting up 4. So the typical sine graph looks like this. Oops. Let's just do it again. So there's the sine of x graph. Goes up to 1, down to negative 1. So if it has an amplitude of 2, now this graph is going to go up to 2 and down to 2, right? And then, so now it has a minimum of negative 2 and positive 2. So right now the range of this graph without any transformation is from negative 2 to positive 2. Well, if this graph is now being shifted up 4 units, then to represent that, we're just going to add 4 to both of those coordinates, right? So the amplitude kind of gives there, and then we just shift everything up 4. So if I add 2 to that, I would have a positive 2 and then a 6, which is my answer E, which is 46. The next one, determine the amplitude of this example. Ugh, don't like this one. So let's go ahead and rewrite that. G of x equals negative 5 times sine of pi times x minus 3 plus 4. Notice that's a plus 4, so that 4 is positive, so you got to write out there it's adding. So same kind of thing here, guys. This stuff all within there doesn't matter. The amplitude in this case is going to be equal to 5. So our graph, doesn't matter if it's sine or cosine, guys, goes up to 5 and then goes down to negative 5. However, now, oh, what am I doing? I'm trying to determine the amplitude. Jeez, slow down. Read the question. So therefore, by rewriting it into this format, let's actually do the formal definition of the amplitude for this then. So I would like to write in there, because remember, the amplitude is not what you're adding to the function, it's what's being multiplied on the outside. So the amplitude is the absolute value of your A, which I didn't do up here, I just did it mentally, which in this case is 5. There you go. All right, so now 48 comes around and says, determine the range of the function b times cosine of ax minus 2b, where a is greater than 0 and b is greater than 0. So determine the range. So we got to understand again, what is impacting the range? This ax is representing inside the function, so that is not going to change the function. The minus 2b is going to change the function, right? So that is going to be impacting here what is happening to the graph. And again, like, to make sense of this, like, we can choose some values here to like better understand this. But anything that has an a is going to have no impact on our graph. Okay? Because a is inside the function. We're only talking about values that are going to be going up and down. So again, let's think about this. If we have a function and b is your amplitude, then we're going to go up to b and down to negative b. Right? And then this negative 2b is shifting the graph down 2 units. So originally, just with this graph, you'd have y equals, like, if you had here, y equals b cosine of x, right? That has an amplitude or a range of negative b to b. But then if you shift it down 2 units or down 2b, you're going to go down 2 more. So therefore, that's going to be negative 3b. And then this would be down 2 units would be to negative b. So if you took this graph here and shifted it down 2 units, you would have this as your range. Kind of confusing. You can also just plug in numbers in for B, like plug in number 1 and plug in 2 because those values are positive, and see if that range would work or that range, because hopefully you understand that the ranges with A definitely do not work. So therefore, it's either going to be answer A and B, which hopefully my description made sense. Since you're shifting it down, it needs to be negative, not positive. And then if you want to verify it, you can use numbers. All right, so this is another analytic. I guess I'm going to have to redo my compression for next year, so for at least to get a little better organized. Thanks, Steve. Man, Steve, you're not being very nice. Determine the general solution. Sine of 2x equals negative 1/2. So you could use the double angle formula here, but I would not really advise because that doesn't really make it any simpler. So remember the double angle is 2 sine of x cosine of x, equals negative 1/2. Well, now what are you going to do, right? Like that didn't help you really at all. So hopefully you remember one thing that we talked about here is since we have this isolated, we can just solve for it and then divide out the 2 at the end. So let's figure out what our solutions are just at negative 1/2. So negative 1/2 is obviously going to be, our coordinate point is negative 1/2 is going to be down here when sine is going to be a negative 1/2. So therefore, I'm going to be dealing with, we could say that the, so I can say the sine of 2x is equal to negative 1/2. All right. So the sine of 2x is equal to negative 2/2. Let's see what these two angles are. So halfway around a circle is 6 pi over 6. So this is 7 pi over 6. So we can say 2x is equal to 7 pi over 6. And then this one is 11 pi over 6. And then we can say sine of 2x is equal to negative 1/2. And then we can say 2x is equal to 11 pi over 6. Now, the interesting thing that's happening here is now we got to divide by, no, actually before that, it's looking for the general solution. There's no restriction on our solutions. So notice here that these two answers, right, are not really like, we can't add one value to one and then to get the other one. Like they don't have, you can't keep on like repeating getting their answers. The only way to continue getting these answers on and on and on is to add 2 pi. So therefore, we need to make sure that our general solution, you can see these all have pi n or 2 pi n. So we're going to add 2 pi n. Okay, and now I just need to divide out the 2. So therefore, when I divide out the 2 here, I get x equals 7 pi over 12 plus pi n. And here I get x equals 11 pi over 12 plus pi n. So we're looking for 7 pi and 11 pi plus pi n. That looks like it's answer B. Be careful. Divide by pi n. Actually, again, another problem that I wasn't paying attention to. Plus pi n, not pi n. I wonder if I got that wrong on my other one. Got to be careful. All right, 50. We're not even halfway done. And well, let's see how far we're doing on time. Cool, hour and 40 minutes. Awesome. This is going to be a long night. So next one says determine the phase shift of the function. Phase shift. So again, that's going to be shifting left to right, right? So, typically that was we're looking to, bx minus c. And when we factored out the b, so if you factor out the b, it'd be like your c over b. And it just kind of gets confusing for a lot of students. They're like, I'm not really sure how this is, working out because you have, we have a B, we have a C. So the easiest thing I told students to do is just, you can always just, again, set it equal to 0, right? And then just whatever x is, that's your phase shift. And if it's positive, it's to the right. And if it's negative, it's to the left. So by adding pi, I get x over 3 is equal to pi. Multiply by 3 on both sides, x is equal to 3 pi. And since it's positive, it's going to be 3 pi to the right. There you go. Easy as that. So, a lot of times I did like to always factor out that term so you can figure out what the true C was for your phase shift. But sometimes it might just be easier just to set equal to 0 and solve. All right, 51. Oh. All right, so 51 says the graph y equals cosine of x plus pi halves is identical to which graph? So my advice to you on this one, guys, a lot of them, if you get the idea, would just be to, you can plug them into your graphing calculator relatively easily. You can also plug in values to make sure that you're going to get the exact same. So the value that I would plug in is, why don't we just say what happens when x equals pi halves? When x equals pi halves, I'm going to get 0. The cosine of 0 is just going to be equal. The cosine of 0 is just equal. Cosine of 0 is just going to equal to 1. Yeah, jeez. Okay, so I'm going to use some of them just by understanding the graph and knowing what would work. And then for whatever ones I don't know, I'm just going to check to make sure. I'm going to check them at pi halves and see if they'd make sense. So let's look at the cosine graph again. So here is cosine graph. Cosine of x. So if I did pi halves, that's basically shifting the graph over pi halves to the left. So typically now I'm going to have an x-intercept from there, and it would look something like that. Okay, so that's basically the graph being shifted. So that's all that happened. The graph just got shifted pi halves to the left. So let's do ones that are kind of some obvious here. If I take this red graph and I reflect it about the x-axis, do I get the purple graph? No. If I take this graph, the red graph, and shift it pi halves to the right, do I get the purple graph? No, because that, like, pi halves to the right would start, here, right, where the x-intercept. So no, that one doesn't work. All right, so now let's look at the sine graphs. Now, the sine graph, y equals sine of x, that starts here. And if you remember, that went like, up, down, and around like that. So obviously, sine of x doesn't work. And if you just take negative sine of x, now obviously we're looking for the purple graph, right? However, if I reflect this, if I take this black graph and reflect it, you can see that it will match that purple graph. So that one looks like it works. And then this one, you got to be careful. This is one where x minus pi. Did I not change that? I did. I forgot to write. Oops, my bad. This one was written wrong. This one was supposed to be, I guess I forgot to insert it. Y equals, that was supposed to be because that one actually is the same as well. That was supposed to be written as pi minus x. So now, if you rewrite that, you'd have a sine of negative, factor out the negative, x minus pi. So now you are reflecting it like you did on this one, but now you're going to be shifting it over pi units, which means that now that point, or shifting it pi units to the right, or pi units to the left. There we go. Let me just double check what I had here, because that was not. So let's make sure I'm in, because I was working on this earlier, so I got time tonight, so I might as well just double check them. I didn't use my calculator, so let's just do x plus. I was using Desmos, and so maybe I was distracted. I don't know. So negative sine of x. Maybe I was just getting distracted on them, but I'm pretty sure when I graphed those three, that didn't work. And then if I flip that around, that didn't work as well. So obviously my answer A is correct, as I noted. And then x minus pi. And I'm pretty sure if I type in sine of x minus pi, that works as well. But then if I do sine of pi minus x, So purple, let's see if that graphs. And then, so the purple should have been, the black one was correct. And then my purple though, yeah. So how did I look at that? Oh, I guess I just have that. I guess I just have my spacing off. So yeah, when you calculate it though, you can see that that purple does not work. So I guess my graph might have been a little off when I'm looking at that, but either way. Geez, all right. All right, so didn't really mean to take a break. Let's keep on going. So the next one says the graph y equals cotangent of x can be obtained by a horizontal shift of the graph of what? Well, obviously, guys, you know, cotangent is not going to be reflected of secant. So, haha, good joke. And obviously, if cotangent, remember cotangent looks something like this, right? So if I reflect this over the x-axis, then it's going to look like more like tangent. So that's not going to work. If it is a tangent function, then it is going to be, it needs to be reflected about the y-axis, which is good, we have here. And the one thing we recognize, and actually one thing we talked about, again, I would just plug these two into your graphing calculator. However, one thing we do notice is if you multiply, if you add or subtract by pi, like that's the period of tangent. So that's not going to change the graph at all. That's just going to shift it over a pi, which again, pi for tangent, the period, that's how long it takes the graph to repeat itself. So when you add pi, that's like adding 2 pi to sine. Like if you add 2 pi to this, it just takes you to the start of a new period. So it's not actually changing a transformation. This is actually going to be our answer. And another way for you, if you remember in our trigonometry, the cofunction identities, pi halves minus x was a cofunction identity. That gave us cotangent. Now you might say, but Mr. McLogan, that has a negative, a reflection about the y-axis. Yes, but remember this is tangent is odd. So it doesn't matter if you reflect the y-axis or the x-axis, that still works. So therefore, when you go ahead and rewrite this, like if I rewrite this as a tangent of negative x and I factor out that negative, then I have that negative pi halves. So you can see it's going to be that same reflection or same transformation, except for the cofunction identity, we're using the horizontal reflection or reflection about the y-axis instead of the x-axis. But again, just check your graphing calculator and you see that those are going to match and D is going to be your answer. All right, another graphing one that I would just say the easiest thing to do is just plug them into your graphing calculator and check. But the graph y equals secant of x never intersects the graph of. Now for this one, you know, we can also eliminate some ones that don't make any sense at all. You know, looking at the unit circle, looking at what the secant graph is. Remember the secant graph is the reciprocal of the cosine graph, right? So, you know, the secant graph looks something like that. Well, obviously that graph is going to cross, you know, a line. So that doesn't work. Obviously, it's going to cross an x squared, even though these go, remember, these approach asymptotes. So x squared is always expanding. So it's always going, it, you know, crosses all domain. So it's always going to cross that. The cosine graph, of course, it intersects with cosine graph. It intersects at every max, at every max and min. So it's not that one. And the cosecant graph is kind of an interesting one because that one would look like it wouldn't cross. But again, if like the cosecant graph is only undefined at the intervals for sine, which I'm trying to, let's see here. But like, I'm trying to, hopefully I do this, but still like these have asymptotes here. So it's only undefined at the asymptotes. It's still going to be approaching there. So the one that at the one value though, you can see though, this purple graph actually doesn't intersect the blue graph. So you can see sine of x works. And again, I would just use your graphing calculator. I'm not going to pull it up. You can just type, you know, those two in and you can see that sine of x is going to be your answer. And what is that, 53? I'm going to just make sure I had, I forgot to select this. Yeah, sine of x is your answer. All right, next one. If k cannot equal 0, what is the range of the function y equals k times cosecant of x? So again, remember cosecant, guys, is the reciprocal of sine, right? So, here's your sine graph, cosecant. So again, let's just say, y equals k times sine of x. Well, that is basically how high and how low the graph is going to go. And the reciprocal function with the cosecant is just a reciprocal of that, has asymptotes at its intercepts. So the range is going to go from negative infinity as high as negative k. Nothing happens in the blue graph from negative k to k, and then it continues from k to infinity. So the only domain here that represents that situation is answer C, which is going to be my answer. Number 55, y equals cosecant of x has the same domain as the function what? Well, obviously cosecant has asymptotes, so sine doesn't work. That has definitely does not have the same domain because that's a horizontal compression, so that's not going to work. Cosecant has the same, not as secant, because cosecant and secant, those have different, that doesn't work. So let's think about cosecant. Now, you can look at the graphs, right? But let's actually take this another way. We know that cosecant of x is 1 over y. All right? Tangent is y over x, and cotangent is x over y. So, and let's just do secant is 1 over x, all right? So if you think about this, like when are values not a part of the domain? They're in when the values of y, or when the values in the, when a function is in the denominator is 0, right? Well, the only functions here that can have the same number for 0 is when the same variable is in the denominator, which is cosecant and cotangent. So cotangent is the only one that would have the same domain as cosecant because those are the same ones where you can have the same number or 0 at the same time for the same values of y. So cotangent works. And again, let's just do a really quick case in point. Let's do the angle pi. Let's say theta equals pi, which is right here, which is negative 1, 0. Well, obviously, 1 over 0, undefined. For cotangent, x over y is undefined, right? You can see they're both undefined for when the angle is pi. There you go. Next one, use the unit circle. Let's just double check it. Use the unit circle to solve cotangent of x equals negative square root of 3 on the interval negative 2 pi to 2 pi. Now, this is interesting. Typically, we usually did the unit circle from 0 to 2 pi. Well, now it's saying you can go negative 2 pi and positive 2 pi. So first we got to figure out, well, what the heck is going to give us negative square root of 3? So we have x over, so just remember, cotangent of x is x over y. And knowing our unit circle, like which coordinate there should give us negative square root of 3. So hopefully you guys recognize, let's think about our unit circle here. I could have a square root of 3 over 2 divided by 1/2. If I have square root of 3 divided by 2, that's going to give me the square root of 3. Now it needs to be negative though, right? So cotangent is negative in the second and the fourth quadrant. So square root of 3, that's x over 2. So let's do that. And actually it's giving you, it's in the second or in the fourth quadrant. Okay, so when is the x coordinate square root of 3 over 2 and the y coordinate? Well, that's going to be at pi over 6, square root of 3 over 2, comma 1/2. So let's see, that answer there is going to be, that angle is going to be 5 pi over 6. And this angle right there is going to be 11 pi over 6. Now again, you got to be careful though. Not only is I answer 5 pi over 6 and 11 pi over 6, so that one, that can't be answer, that can't be the answer, and that can't be the answer. But it also is the negative version, which is negative pi over 6 and negative 7 pi over 6. So even though we got our two answers here, we could figure out our answer just by the green. We didn't even have to worry about the negative. But just remember that domain is a little bit different than what we're used to. All right, number 57 says use the unit circle to solve cosecant of x equals 2 radical 3 over 3. So remember that the cosecant of x, guys, is 1 over y. So how we got 2 square root of 3, I bet we probably did 1 over the square root of 3 over 2. And then we multiplied by your denominators, and that's how we got the 2 radical 3. So the y coordinate 2 over 3 is going to be in the first and the second quadrant. Now notice this is between negative 2 pi and 2 pi. Again, the same intervals. But if my y coordinate is going to be the square root of 3 over 2 for the y coordinate, I'm going to be dealing with this point up here, which is pi over 3. So that is going to be 1/2, comma, square root of 3 over 2. So my 2 points here is going to be up here and up here. So this angle is going to be pi over 3. And again, I'm just doing the positive versions. So pi over 3, where is my pi over 3 I got? So that one works, and that's it. So now before I just go ahead and select, oh, D is my answer, I know this answer has to exist as well, which is just going to be 2 pi over 3. And I notice that this doesn't have 2 pi over 3 either, right? So therefore, this is none of these. Now the final answer, the answer we should have been looking for, the answer that would have been the correct would have been pi over 3, 2 pi over 3, and then the negative versions of that, which would be 3 pi over 3, which would have been a negative 4 pi over 3, and a negative 5 pi over 3. So they're all a mix and match here, but the end and final answer here in this example is actually 50 is E, none of these. All right, moving on to another period function. And this one is for cotangent. So remember the period of cotangent is pi. So in this one I have pi divided by b. So my b again is what is being multiplied by my variable, which is pi over 8. So this is b or pi divided by pi over 8. Multiply by your reciprocal. And hopefully you guys, you just get that 8 over pi. And then you guys see that's going to be 8. So there you go. Sorry guys, I'm just going to go ahead and check real quick back over to my stream health just to make sure. All right, perfect. All right, the next one says, what is the period y equals 2 secant of x minus 7 halves pi x? What is the period? So remember, period again is 2 pi divided by b, right? So again, let's rewrite this in that format. So let's change this around. So 2 times secant of, this is where my input variable is, right? So let's write that first. So it's going to be a negative 7 halves pi plus pi, because that's a positive pi. Now we don't really care. Oops, there's an x there. We don't really care about the negative, so you could factor that. You can factor that out, so it's a negative. So then we have 7 halves pi x minus pi. All right. So now, again, we're just looking for what is our b in this case, which is 7 pi halves. So I have 2 pi divided by 7 halves pi, or 7 pi over 2. And again, guys, what happened? 7 halves. Yeah, okay. Yeah. So then now multiply by your reciprocal, which would be 2 over 7 pi. Or, yeah, let's put the pi in the, make sure it's in the denominator in this case. And 2 over 7 pi. Now my pi's divide out, and I end up getting a 4 over 7. And the pi's divide out, so no more pi's. And just make sure it's 2 times 2. So my answer, 59, is A. All right, last couple problems here is, I believe, hope so, getting on a trig, yeah, analytic trig. So I'm almost done. I'm almost done, at least in the trig, and then I'll take a quick little break for you guys. All right, so the next one says cosine inverse of negative square root of 3 over 2. These are just some unit circle problems. Make sure you guys are aware of these. Just remember your domain restrictions for cosine inverse is going to be in these first two quadrants. So cosine of negative square root of 3 over 2. Those two answers, cosine is, let's see, negative square root of 3 over 2. Now my brain is third. So that is going to be here and down here. Okay, so that is going to be a 5 pi over 6, which is E. Let's check my answer. Good. The next one is sine. Remember the restrictions on sine is the fourth and the first quadrant for negative 1/2. So for positive, negative 1/2 is going to be, down here. Down here and down here, but this is the only one. Remember, you got to stay within the restriction. So that is going to be negative 1/2 is going to be a negative pi over 6, which is answer C. Good. And then number 62 says the arc sine of sine pi half. So remember, let's do the inside first. Remember, this is a composition of functions. So let's look at the unit circle. So the sine of pi here is the y coordinate, which is 0. So it's really the arc sine of 0. So the sine of 0, the arc sine of 0 is basically what angle then is when sine is equal to 0 for, oops, I forgot to write in that answer. That's supposed to be I missed those answer choices. Sorry about that, guys. It doesn't matter. It's not an answer choice anyways. But that was supposed to be negative pi, and that was supposed to be pi. Okay, so now we just got to figure out, well, what angle is then between 0 and pi for that gives us 0, for when the y coordinate is going to be equal to 0, and that is just 0. Like this angle here, 0, gives us y equals 0 when you take the sine. So sine of 0 is 0. All right, another composition here. This is the secant of arc tangent of x. Now this one's kind of interesting because we don't really have anything we can do, right? There's like literally nothing to take that. So we can think about, what are we doing? Are we multiplying them? Like, how are we going to get the rest of this? And if you are into your identities, that could kind of maybe trip you up and you might want to jump to that. But remember, let's just draw a triangle. So if you can't evaluate it based on the unit circle, then draw a triangle. So we don't know what the angle is. Remember, this is the arc tangent. That's a value, right? That's a value of x. So let's say here's our theta. So if I want to find the arc tangent of x of this triangle, then basically the tangent is going to be x over 1. Now, if I want to find the hypotenuse, I would just do x squared plus 1 squared is equal to the hypotenuse squared. And therefore, the hypotenuse is equal to the square root of x squared plus 1. So the triangle that we are referring to is x squared plus 1. So now, if they're asking us for what is the secant, well, remember, secant of this triangle is going to be the hypotenuse over adjacent. So instead of 1 plus x squared or x squared plus 1, you can see the answer is C. All right, so now I'll just go and take a quick little break here, guys, before we get into some more analytic trigonometry. There was definitely some analytic trigonometry that was sprinkled into this last unit, and I just didn't really think about that until now that I went live. So for those of you that have been joining in or have stayed with me for these 2 hours, congrats to you. Hopefully this has been a good review for you so far. Definitely, if it has been a good review, you can definitely give me a thumbs up just to kind of let me know, and then thumbs down. I know that this was a complete waste of my time on a Sunday evening for you guys, but hopefully it's been helping you guys out so far. And if you are watching the replay, please check in the description. I will make sure that I have a copy of this for you to download yourself, as well as not only a download, but then also a timestamps for you to go to the different chapters so you can kind of see which problems you did. And I'll also have the answers available for you guys as well. Ethan says, does anybody have to know this beforehand? I guess I came in late. I don't know. I mean, Ethan, I'm just going through everything we've learned in precalculus. So I'm just hitting on different chapters and different problems that we've done through these chapters. So thanks, Money Monster. I appreciate it for you guys. And Quantum is pre-calc hard. I'm taking it next year. Well, Quantum, hopefully my channel will be a great resource to help you out with that. And sorry, guys, I do see a couple requests for me to be able to get through the problems, but unfortunately, I have too long of a live stream today to really be doing any additional questions for you guys. But let's see here. We are going through. All right. Well, let's continue on. Let me see. All right. Hey, Alexandra, I see you. This is really what my future homework is like, Emma. Well, I don't know. I mean, it could be. I guess it really kind of depends on how the class and everything you're taking. So, but this is just some multiple choice questions that I wanted to cover. That's a good review for my students as they're breaking their EOC. Okay, going to get some relief. It's a relief. All right. And my voice is starting to go too, so we'll see how I do for this. All right, the next one is, which of the following does not equal the sine of x? All right, so this is going to be going in with our identities. So what did I do for this one? I don't even remember. I'm like losing now. Oh, I think I just said looks at the graphs. Obviously, this one definitely equals sine of x because that's a odd function, so that's a negative. So and then you're negating that, so that one works. Oh, that's what it equals. If you remember your identity, sine squared of x plus cosine squared of x equals 1. So therefore, 1 minus sine squared equals 1 minus cosine squared, equals sine squared. So that square root of sine squared is obviously just equal to the sine of x. Tangent of x over secant of x, so that's going to be the sine of x over cosine of x times 1 over the cosine of x. Obviously, that does not work. That does not divide out to give you sine. So that is your actual answer in that case. And then these are just going to be transformations. If you shift the cosine graph pi halves to the right, that actually takes you to sine. And then this would be your cofunction identity, which is going to take you to sine as well. So that's a reflection and a shift. So both of those work. And you can verify by the graph as well. I should probably write those on those other two to make sure, verify, using graphing technology. Let's see, maybe I can even find... How long were those? I don't think they were that far. Yeah, let's just, no, not that one. Yeah. Verify by the graph. Just so therefore when people are printing this out and they want to make sure how I got my answer and they're not watching the live stream, you can just use graphing technology for those. And I think those are... The rest of them I think you can figure out. All right. So next one is a simpler expression for secant of y plus 1 times secant of y minus 1. Well, we'll recognize that's a difference of two squares. So secant squared of y minus 1. Now, hopefully you recognize that's a Pythagorean identity. And, the one thing I know is if I have my sine squared of x, plus my cosine squared of x, equals 1, and I want to get to secant, then remember secant, guys, is 1 over x, right? So therefore, I can just divide everything by cosine. Oh, sorry, these are all y's. Well, it doesn't matter. It's the identity. Right? But again, notice the cosine squared. Notice 1 over cosine squared is going to give me secant. So sine squared over cosine is going to be a tangent. squared of y, cosine of square root plus 1 equals secant squared of y. So now this is my Pythagorean identity for secant tangent. So instead of trying to memorize this for your exam, just remember that, and then just remember the sine squared plus cosine squared equals 1, and then remember you can divide by either cosine or sine. So I have this, and then if I subtract the 1 over there, I'm going to get tangent squared. So therefore you can say that's answer C. Number 66 is how many solutions between 0 and 2 pi does the equation 3 cosine squared of x plus cosine of x equal 2 have? So, one thing I noticed with this problem is it kind of reminds me of a quadratic. 3x squared plus x equals 2. And remember, for quadratics, if you had two terms you could combine, then you just combine them and you solved. But if you had two terms that were not like terms, then we typically wanted to look into setting them equal to 0 and factoring, or using some other method to graph it so we could solve. So typically the best thing we'd want to do here to solve this, at least in this problem, we'd probably set it equal to 0, and then we'd go ahead and factor that, right? And that is, let's check to see if this is factorable. 3x squared plus x minus 2. So if we factor that, that'd be 3x times x. What two numbers multiply to give me 2 to give me 1? So two numbers that need to multiply to give me negative 2, but again, I need to get them to be a positive, so that's going to be a 1. And let's see, that'd be a negative 2. So let's make sure our outer and our inner work. 3x times 1 is 3x, and that's a negative 2x, and that gives you a middle term 1x. Sweet. So in our case, we haven't even done this yet. Let's actually get to this problem. Cosine of x minus 2 is equal to 0. Well, I can factor this just like I can factor a quadratic. So I have 3 cosine of x minus 2 times cosine of x plus 1. Now I can go ahead and use the zero product property to solve for these. And one thing, we looked in class, like this one, hopefully my students recognize this one. Like this one isn't that bad. The 3, or we're going to have two solutions here. So we have cosine of x is equal to 2/3, right? And then we also have cosine of x is equal to negative 1. Well, I know cosine of x equal to negative 1 is at pi. So that's one solution. And then cosine is equal to 2 pi over 3. Like, we're not used to 2 pi over 3 on the unit circle. So one thing I can look at is, what about the graph tangent or graph cosine for the graph? Like, here's a period, right? And here's it at 1. So 2/3 would be like right there. And you can see that there's going to be two values. Let's draw a better line here. There's going to be two values where the graph of cosine is equal to 2/3 within the period. So this has two solutions right there. And therefore, two solutions for this one and one solution for that one. We don't know what those two solutions are. You could obviously use your graphing calculator or scientific calculator to figure them out, but it doesn't really matter. We know this solution is pi, but again, it's just asking for us for how much, so let's not go to that step and let's just count them to get to 3. All right, the next one says, if cosine of A and cosine of B is equal to sine of A and sine of B, then cosine of A plus B. So what that means is we need to, get tired. We need to, again, we notice this is the sum of two angles, so let's go ahead and use the sum of two angles for cosine. So that's going to be cosine of A times the cosine of B minus the sine of A times the sine of B. All right. Now the nice thing it says is cosine of A cosine of B, which is right here, is equal to sine of A sine of B. So I'm not even going to, well, I guess I might as well. Sine of A times the sine of B minus sine of A times the sine of B. And you guys can see, obviously, they subtract to give you 0. So therefore, there's your answer. The next one. If sine of A times cosine of B is equal to negative sine of B times cosine of A, then sine of A plus B. So now we're doing the sum formula for sine. So this is sine of A, times the cosine of B plus cosine of A times the sine of B. All right. So now let's see, what does this one say? So sine of A cosine of B is negative sine of B cosine of A. So negative sine of B times cosine of A. Well, you notice that it's the same thing. It's just the terms are like switched around, right? So they just, again, you're just going to get to 0. So those just add again to give you up to 0. No worries, Ethan. I got you, man. I know I haven't hopefully I can hang with you guys for almost done. But we're almost there. We're past halfway, and we're a little bit over a couple hours here, 2 hours, 20 minutes. So we'll see how we go. All right, next one is the sine of negative pi over 12. So we could use the half angle formula for this, or it looks like my solutions kind of look like ones for the sum and difference of two angles. So that's exactly what I'm going to do. And I'm going to think in this example, you know, how could I subtract two angles that would give me like negative pi over 12? Well, again, I could rewrite this as the sine of, let's just think about this. What if I did 4 pi over 12 minus, or 3 pi over 12, sorry, minus 4 pi over 12? Well, obviously that's going to subtract to give you negative pi over 12, right? Which is exactly what our angle is. So this is a different way to represent that answer as a difference of two angles. And now I can use the difference of two angles formula for sine. So that would be the sine. Now again, these can be simplified. So 3 pi over 12 is the same thing as pi over 4. 4 pi over 3 is the same thing as pi over 3. So this is really the sine, and I'm just going to write it out because I don't want to make the mistake. Sine of pi over 4 times the cosine of pi over 3. Please make sure you're aware this is not, don't make those negative like those are in their own parentheses. Okay, you're subtracting the two angles. That's not a negative angle. So minus the cosine of pi over 4 times the sine of pi over 3. So the sine of pi over 4, let's go ahead and simplify this now. The sine of pi over 4 is square root of 2 over 2. Cosine of pi over 3 is going to be 1/2. Minus cosine of pi over 4 is square root of 2 over 2. And the sine of pi over 3 is the square root of 3 over 2. And when you multiply those out, you get square root of 2 over 4 minus the square root of 6 over 4. And now you can combine those to the same denominator. Which looks like my answer is D. Boom. Awesome. Next one, number 70. Again, it's kind of weird, but if you recognize, like, that's kind of like the same formula that we just kind of did, right? Sine of an angle, cosine of an angle, cosine of an angle, sine of an angle. But it's addition instead of subtraction, and we already actually did the sum of two angles, actually right here, right? Sine of an angle, cosine of an angle, plus cosine of an angle, sine of an angle. So we're adding the two angles, guys. So basically all this really is it's definitely the sine formula, right? It's not the cosine of two angle formula. And again, my students have the formula sheet. I'm assuming, and hopefully maybe you guys will have, you don't have to memorize these formulas. If you do enough of these practice, then you should have these memorized like I do. But, you know, my students will have access to the formula sheet. So that's why I'm not, you know, presenting again the formulas. But this is just sine of 133 degrees plus 58 degrees. And therefore, that just adds up to the sine of 191 degrees, which is B. All right. Question number 71. Now, this one is something we could not use really the sum and difference of two angles, right? Because we have the 22.5. So what this does is this screams to me the half angle formula. And the half angle formula, if you remember, is, you know, plus or minus the square root of 1 minus cosine of theta divided by 2. So the important thing, though, is we need to understand that theta divided by 2 is equal to 22.5. So therefore, theta is equal to double that, which is equal to 45 degrees. All right. So that's kind of an interesting thing here. We got to remember when we're using the half angle formula, the formula deals with theta, not theta pi halves. So therefore, we're going to be plugging in. When I plug this in, it's plus or minus the square root of 1 minus the cosine of 45 degrees. So again, the formula is for theta, not theta over 2. So let's go ahead and now do some algebra here. Obviously, 22.5 degrees is in the first quadrant, so we don't need to worry about the plus or minus. It's just going to be positive. And you can see all the answers are positive anyways. So it's 1 minus 2 over, let's do this a little, give myself a little more room. So 1 minus square root of 2 over 2 divided by 2. And if you remember, what we want to do is get rid of the denominator. So I multiplied by 2 on the top and the bottom. And what that gave me was a 2 minus the square root of 2 over 4. And then you could break up the radical into the numerator. So 2 minus the square root of 2 over the square root of 4, which would then give us that answer, which was E. Boom. So this is one that was, not kind of simplified for there. All right, let's go and work on question number 72. So now we're going to get on to solving. And for this one, you can see that we have this double angle. Now, in this one, we can't like divide out the 2 like we did in the last example. We're actually going to, excuse me. And this one, what we'll need to do is actually use the double angle formula. So remember, the double angle formula for sine is going to be the 2 sine of x cosine of x is equal to 0. Well, now I have an equation that I can factor out common term, which is cosine of x, and a 2. So if I factor out a 2 cosine of x, I'm going to be left with a 1 plus sine of x equals 0. So now I have a product equal to 0. So I can say the cosine of x is equal to 0, and 1 plus the sine of x is equal to 0. So when is cosine of x equal to, when is cosine of x equal to 0? When is cosine of x equal to 0? Well, cosine of x is equal to 0 at when x is equal. So again, notice the domain restrictions, right? That's important. So it's only equal to 0 between 2 pi. So cosine of x is equal to 0 at based on the unit circle at pi halves and 3 pi halves. So let's see which ones have that. Pi halves, 3 pi halves, pi halves, 3 pi halves. So this one doesn't work. And pi halves, 3 pi halves. All right. And then this one would be sine of x is equal to negative 1. So when is sine of x equal to negative 1? Well, that is when it is pi. What did I have the answer on? Why doesn't that one work? Negative 1, which is 3 pi halves. Oh, okay, yeah. Oh, geez. So sine of x is equal to negative half as x equals 3 pi halves, which is a repeat of this answer. So therefore, answer for question number 72 is going to be A. All right. On to 73, and then we'll go ahead and take a break. Awesome. Guys, we're almost, let's see, we're now done with analytic trigonometry. So yeah, we're still almost done with quarter 3, and we still got quarter 4 to go. But we're getting kind of on the trail end here. Hopefully I'm thinking probably, hopefully by midnight, I should be able to finish. Hopefully. So, and this one is a solve cosine squared of x divided by 2 equals cosine squared of x. All right. So we're going to use the half angle formula for cosine. Now again, remember the guys that this can be rewritten as, this is kind of important, cosine of x over 2 squared equals cosine squared of x. So cosine of x over 2, if you remember the half angle formula for that, you can do the plus or minus, but again, it doesn't really matter here. That's going to be 1 plus cosine of x divided by 2. But again, that whole thing is squared equal to cosine squared of x. Well, obviously, guys, you can see the squared goes out, so we're just left with 1 plus cosine of x over 2 equals cosine squared of x. Well, let's get rid of the 2. So let's multiply by 2 on both sides. And now we have 1 plus cosine of x is equal to 2 cosine squared of x. And now we can see we have cosine of x on both sides. Let's set it equal to 0. So we'll subtract the cosine of x and we'll subtract the 1. And now let's just go ahead and factor this, guys. Treat it again. Treat it like a problem, like 2x squared minus x minus 1. Like, how could you factor that? Well, that's 2x, x. Let's see, that needs to be a minus 2 and a plus 1. So then this can be factored in the same result. So we can do 2 cosine of x plus 1, and then times cosine of x minus 1 equals 0. All right. And then, so we solve, set them both equal to 0. So we have the cosine of x equals negative 1 over 2. And the cosine of x is equal to 1. So now let's look for our solutions. Cosine of x equal to negative 1/2. That's going to be in, let's see, it's going to be up there and down there. So that's going to be at 2 pi over 3. And at 3 pi over 4 pi over 3. So 2 pi over 3, 4 pi over 3. Well, I think that's the only answer. Let's just double check this last one. Cosine of x is equal to 1. Obviously, that's only going to be at 0. X equals 0. So there you go. Answer is E. 473E. Perfect. All right. Let's go ahead and continue. And, yep, so now we're on applications of trigonometry. Let's just go ahead and take a break, guys, for those of you that have just either joined in or have been with me for way too long getting through our pre-calculus review. What's up, Aiden? I am a funkin' gamer. Agaro. Yashib, Gary, Ethan, I'm back. I forgot for all my Algebra 2, and I'm still okay as a recap. Good. Well, Ethan, we're getting into some fun word problems. So this is everybody's This is everybody's best part. The Kitty Gamer, you got to go. Too late. Class tomorrow. Remember, don't forget. Kevin, your videos have taught me more than like my teachers. Well, awesome, Kevin. I'm very happy to hear from you. Alex says, are all the people on this in your class? I doubt it. I mean, they got school tomorrow, and it's 10:50 at night. I did tell them I was going to be going live on Saturday at 9 a.m. And then that didn't happen. And then I was planning on doing Saturday at 1 o'clock, and then that didn't happen. And then I was going to do today at 1 o'clock, and that didn't happen. Then I was going to do today at 7 o'clock, and that didn't happen. Then I was going to do 7:30. That didn't happen. 8, that didn't happen. And then I think finally I went live around 8:30, and then everything got messed up. And Cobble 10, a super chat for $5. Well, thank you very much, Cobble. I really appreciate you supporting the channel with the super chat. And I've gotten more super chats on this time than all my live streams. I mean, I'm not sure if I can support myself by doing 2-hour live streams, but I really just appreciate you guys throwing some support and just kind of let me know that, my videos will help me out. And for all of you guys that are adding into the chat, let me know. That is greatly appreciated. My voice is starting to go, which is kind of cool and kind of not cool. I kind of like it just because it reminds me like, yeah, you're doing work, like you're doing what you're supposed to be doing. That's awesome. But that also sucks because I don't want to not be able to talk by the end of this. So hopefully we'll just keep on going. I still have some decent amount of water, and we'll go from there. Bunny Dream, I have sequence series. Yeah, unfortunately, we didn't have to teach sequence series this year, so we're not going to have to get to it. So it's not on this stream. So I do apologize for that. But I used to teach sequences and series in pre-calculus. So, I do have some videos on that as well. Well, awesome, Alex. I'm glad I got your, this is hitting you just in time because, I wanted to do this live stream earlier and I just didn't have the capability to do that. But now we are back on. So let's try to figure out some word problems. All right. So the main thing on word problems is, we're going to try to solve these as kind of soon or as easy as possible, but also by kind of sketching a graph. So 74, to get a rough idea of the height of a building, Bartholomew paces off 50 feet from the base of a building, then measures the angle of elevation from the ground to the top of the building at that point to be 58. Oh, I also thought I should mind, guys. I am going to be using my graphing calculator to solve these. All right. Now, up to this point, I only used it a couple times just to verify some graphs. Now, it's important when you're using this. When I had to I graphed the trigonometric functions. When you're graphing trigonometric functions, make sure that you are in radian mode. Now that we're doing word problems, you notice that we're in degrees. So I'm going to go ahead and change my mode to degree mode. Okay, very important. Make sure when you're plugging in like the sine of something, a cosine of something, make sure you understand if it's in radians or in degrees, and then make sure you have that correctly noted either on a graphing calculator or, scientific calculator. And for this one, I'm just going to use my graphing calculator because for all the live streams that I was supposed to bring this home, I never did, but this time I remembered. So let's see here. We paced off 50 feet. All right. We found an angle of elevation. Remember, angle of elevations are angles above the horizontal. 58 degrees. And obviously we have a building, so we're going to assume there the building is going to create a 90-degree angle with the ground. And we want to find the height. Okay. So now we just really want to use our trigonometric function to see which one would work. And you have opposite and adjacent, so we can write a tangent of 58 degrees is equal to h over 50. Now, again, guys, I am not going to retype in everything. I'm just going to plug this in. And, hopefully I'm assuming that you guys from this point on can go ahead and find the correct answer, which is going to be D. Ethan, actually, if you check back in the stream earlier, I did a little bit on the binomial theorem, but not really part of the binomial theorem, but just a little bit on binomial expansion. All right, that was a quick little side cap. Next one, 70, the one students hate. A boat leaves a harbor and travels at 20 knots, heading due east. Let's draw a picture. So it's heading 20 knots, due east. Cool. So it traveled due east for 2 hours. So that means it traveled. Now, again, if you're not used to knots, just repeat this with miles per hour if you want to. It's not going to change the answer that you get. But knots is a rate, and therefore the distance is going to be in nautical miles. So if you travel 20 knots for 2 hours, that means you have traveled 40 nautical miles. Okay? So we have 40 nautical miles, and then it changes course to a bearing of 150. Now remember, when we're doing bearings, we got to create a new northeast southwest, right? Northeast southwest. Now it's also important for us to understand that 150 degrees from a bearing starts due north. So from here to here is 90, and if you did 150, that means you went an extra 60 degrees. And then you continue the same speed for another hour. Okay, so that means from there, you only traveled 20 nautical miles. After the entire 3-hour trip, how far nautical miles is the boat from the harbor? So basically the question is asking us, how far are you from here to there, which we're just going to call the distance. Now, if we know that this is 90, then that would be 60, if here's 180 and you traveled 50, so then that means that's 30, right? And that's 90. So 90 plus 30 is 120. So you could say that this whole angle, so that angle from here to here is 120 degrees. So again, notice I'm actually going to change. Let's put the green, let's put that up top. So now, a lot of time you draw the picture and you're like, all right, you got it. But sometimes it's just best to redraw it with the information you have. So we have 40, 120, 20, and then this is our unknown, which we'll call d, the distance. Well, I recognize this as an angle side angle. So therefore, to solve for d, we're going to want to use the law of cosines. So you can label these a, b, and c. Doesn't really matter. You know, however your formula sheet is. And, you know, then this would be basically bit d. But hopefully, as far as then the formula goes, you know, it's d squared equals 40 squared plus 20 squared minus 2 times 40 times 20 times the cosine of d, which is 120 degrees. And therefore, d is equal to the square root, and I'll just show you what I got, so you can verify this. So it's 40 squared plus 20 squared minus, I'm going to use parentheses, 2 times 40 times 20 times the cosine of 120. And I'm getting 2,800. Okay, and then when you take the square root of that, square root of that answer, I get 52.9, which is 53. Boom. So 53 is the nautical miles that you have. All right. Next one. So 76. A 20-foot ladder makes an angle of 62 with the ground as it leans up against a wall. So again, we have another triangle. It makes a 62-degree angle with the ground as it leans up against the wall. How far up the wall? So this is 20 foot. How far up the wall does the ladder reach? So again, we're kind of looking for like the height, I guess, like, you know, really how far up it was. And we're not going to want to use tangent in this case. We're going to want to use the opposite and the adjacent. So therefore, we're going to want to use sine. So we could say the sine of 60 degrees equals h over 20 feet. So basically, I'm just going to do 20 times the sine of 62. So 20 times the sine of 62. 17.66 would be my answer B. Good. Number 77 does not look like that fun. It says at a distance of 34 feet from the base of a flagpole. So let's go out 34 feet. So we have a flagpole at the base of a flagpole, 34 feet. Okay, at the base of a flagpole, from the base of the flag, the angle of elevation to the top of the flagpole is 5 feet tall. Oh crap. Okay, so. Oh, that's from the base. Sorry. All right, we don't know the flagpole, so. The top of the flag, that is 5.1 feet, is 48.6. Angle of elevation to the bottom of the flag is 44.6. The pole extends 1 foot above the flag. Find the height of the pole in feet. You know, I was thinking of this one a little bit different. So you have, okay, so let's eliminate this line here. I guess it really doesn't matter because it's still the same. So we're going to have a flag, big flag, and then we have a little pole, right? So we have a flag, flagpole, and there's a flag. All right, so actually, let's actually redraw this. Ah, dang it. Okay, so there's your flag. Right? It has a little bit, it says it extends like 1 foot above the flag. So the angle of elevation, 34 feet away, to the bottom of the flag, right, is 48.6. Now, it does tell us I'm sorry, that is 48.6. The angle of elevation to the bottom of the flag is 44.6. Let's go ahead and do that. Come on. There you go. So that's 44.6. To the top of the flag, that has an angle of elevation of 48.6. Now, they actually give us the distance of the flag, or the height of the flag, which is 5.1 feet. And they give us this distance, which is 1. So really, we don't really need to figure out, this 48.6 is really irrelevant. We really just need to figure out this height. So we really just need to figure out the height of here, 44.6, height, and 34. And then we find that height and then just add 5.1 and add 1. So we don't really need to figure out, this 48.6 is really not going to be relevant to us for this problem. So in this case, we're just going to have the tangent of 44.6 is equal to h over 34. So I'll do 34 times the tangent of 44.6. And I get 33.52. And so that I can say h is equal to 33.52. And then add 5.1 and add 1 foot. And 5.1 and add 1, and I get 39.6, boom, which is answer E, which is correct. The next one says 78. An airplane is flying east at a constant altitude of 30,500 meters when first seen to the east of an ambitious precalculus. I don't want to confuse you guys with that. When it is first seen. All right. Don't want to get you guys confused with some random stuff. So an airplane is flying east of a constant altitude when it is first seen at east. The angle of elevation to the airplane is 63 after 63. So here's an airplane. To the east is 33. After an angle of elevation, after 33 seconds, it's 51.6. So here, it is seen. So here's the airplane in the sky, right? And that's at an elevation of 30,500. And then, so that one, let's go to here. This has an elevation of 63. And then after 33 seconds, the angle of elevation is 56.1. So actually, it's flying away. So the first one is nice and short, and then it's farther away. So you can see that the plane here to the east, so you can say, all right, it's flying east when it's first seen to the east of the angle of elevation to the airplane is after 36, the angle of elevation is 56. Well, either way, you can see the angle of elevation is falling, right? So, I mean, forget about the east or the west. You can see that if you're even to calculate it, you can see the angle of elevation is getting smaller and smaller. So it's, you know, flying. All right, so maybe I should just rewrite this. Here, I'll just redo it. Because it does say to the east. So if we're going to look at this, yeah, let's just look at this over here. All right, so you have an airplane. First, it's being seen here at an angle of elevation of 63.6. Airplane is flying this way, right? So after 33 seconds, now the angle of elevation is smaller, right? Which is 56.1. So we see that the plane is going farther, but that it's saying is find the approximate speed of the airplane. Well, basically, before we can find the speed, we got to figure out, well, how far did it travel, right? So, let's kind of look at, there's kind of two different triangles that we're going to want to discuss here. So, not this one. Let's look at it this way, because the plane is 30,500. So we have one triangle. So we have one triangle that looks like this. Still a right triangle. It has 63.6. And let's see, this distance is going to be 30,500. Then the other triangle we have is after 33 seconds, now the angle of elevation is 56.1. Same elevation, right? Okay, so let's call this distance that he traveled x2, and let's call this one x1. Now, if we want to find the distance that they traveled, we basically just take distance x2 minus x1, and that's going to give us d. So we can say d is equal to x2 minus x1. Well, we got to find x2 and we got to find x1. So this is at the end of my thing, but hopefully we got some room here. So I can write, let's do tangent of 63.6 is equal to 30,500 divided by x1. And therefore x1 equals, I'm just going to approximate this. You got to multiply by x and then divide. So really what you're typing in here is 30,500 divided by the tangent of 63.6. And I get here 15,140.3. Now I'm going to store this. So store as alpha A. And then let's do the next one, which would be tangent of 56.6, that equals 30,500 divided by x2. So therefore x2 equals, so that'd be 30,500 divided by the tangent of 56.6. And I get 20,000, and I'm going to store that as alpha b. So that's 20,111.04. All right, so that means D is equal to, let's just do that. So we'll do alpha B minus alpha A, and therefore I'm getting 4,970. Now, that's how many meters that they traveled. But again, this is asking for the rate or the speed in meters per second, right? So basically, in 33 seconds, how many meters? So I'm just going to take this answer and I'm going to divide it by 3. So I'm going to say the speed, which is in meters per second. So I'm going to take 4970.71 and divide it by 33 seconds. And that gives me 150.62. Dang it, that's 9 things. Did I change? Oh, did I take, what is that? Alpha B divided by alpha A does not give my answer. Where's my answer? I get 162. So that was my answer, 162, that I got when I did this. All right, so my alpha B divided, oh, did I not store that? My alpha A, did I not type? All right, I think my A is wrong, or my X2. It is. It's not 56.1, it's 56.1. Jeez, 30. So that's wrong. All right. So this is wrong. This is not 56.1, it's 56.6. Be careful. All right, so let's do that again. So we're going to do 3,500 divided by tangent of 56.1. Now the nice thing is I can just store this as alpha b again, and no harm, no foul. So my b is wrong, but I can quickly fix this because that wasn't an answer choice, thankfully, right? So So that's 20 for 95.1. And now I do alpha b minus alpha a, and I get 53. Keep on using the wrong marker. 53, so that's okay. I take that answer, divide by 3, and I get 162. Sweet. There we go. All right. Question number 79. Question number 79 says, in the triangle EFG, if F is 95, G is 53, and E is 12, what is the approximate value of G? So we can see we have an obtuse triangle, right? So let's just draw some kind of random obtuse triangle. Let's call this F, which is 95. Then that's little f. Let's call this G. That means that's 53 degrees. That's little g. And then that's big E. And this is little e. Now, the nice thing here is if I want to find for G, well, I notice I have two angles. So if I have two angles, I can just figure out the third angle, right? So E is equal to, 180 minus 53 minus 95, which in this case is going to be 32. So now I have a ratio of a side and an angle. So I have E is 12. Don't know why I didn't write that in there. Let me just write that in. I just want to make sure. 180 minus 95 minus 53 should be 32. Yeah, okay. It's been late. I've been doing a lot of problems. I was like, might as well just double check it. So now I can use the law of sines, right? So when using the law of sines, let's see here. I'm going to be solving for a side length, so I'm going to want to be on top. So I'll do 12 over the sine of 32 is equal to G over the sine of 53 degrees. And then basically you can apply the cross product and just do 12 times the sine of 53 divided by the sine of 32. And I'm getting 18.1, which is answer C, 79. Sweet. All right, now let's get on to the area. And the area, you can see that we're giving us all the sides of the triangle. We don't need to use, we could draw the triangle and see if we're going to use, a formula. But I noticed that when I have all side lengths, I'm going to want to use Heron's formula. And to apply Heron's formula, we need to figure out what S is, which remember was the sum of all the angles divided by 2. And so therefore 15, that's 24, so that equals 12. And then remember, you basically just take the square root of 12, and then you basically take S minus each one of those lengths. So 12 minus 7 is 5, 12 minus 8 is 4, and then 12 minus 9 is 3. And we get the square root of 12 times 5 times 4 times 3, 720. Now, did I not get this answer before? I'm not sure why. Let's try to think what Yeah, okay. And then you could think of, this becomes 720. Now we want to think of square numbers that are going to evenly divide into that. And I think of 1 squared, let's see, I think of 36 that evenly divides in there. No, but that's on, so what I did, 720. I think I just reduced this in my calculator. 720 divided by 144 is 5. And so therefore, I just kind of worked backwards. So I took these answers and I said, all right, that gives me a square number of 144. That is 36. 16 times 16, I don't even remember. I keep on forgetting that. That's 256. That's a big number. 17 times 17, 289. And 18 times 18, 324. So I thought about these like that doesn't divide into that. That doesn't evenly divide. That doesn't evenly divide. Let me check 144. And of course that worked. And it works in there 5 times. So therefore that answer is B. 36 does go in there as well. 720 divided by 36. That goes in there 20 times. So you just have to simplify it one more time. And that would work. It doesn't go in there, 15 times. So you just it goes in there 5 times. So 36 does work. Just got to be careful with simplifying the radical. All right. Next one says 81. 2 boats start at the same point in speed away along courses that form a 110-degree angle. If one boat travels at 24 miles per hour and the other boat travels at 32 miles per hour, how far apart in miles are the boat after 30 minutes? So again, we're at 30 minutes, not at an hour. So let's see. They're just 2 boats. They're just traveling. They're forming a 110-degree angle. Right? So one's going at 24 miles per hour. But that's so for 1 hour, it would travel 24 miles. But in 30 minutes, which is a half of an hour, it only travels 12 miles. The other boat is traveling at 32 miles per hour. So in 30 minutes, it would have only traveled 16 miles. So again, they're asking us after 30 minutes, how far are they apart? Again, guys, we're looking into, let's call this D. So this is big D. We're looking for the value of D. So again, this is going to be a law of cosines. So I'll use that formula. D squared equals 12 squared plus 16 squared. This is the law of cosines minus 2 times 12 times 16 times the cosine of 110 degrees. So D equals the square root. I'll plug it into my calculator so you guys can verify. Plus 16 squared minus parentheses 2 times 12 times 16 times the cosine of 110 degrees. 531, and I'm going to use the exact answer. And that's a 23. So D equals 23, which you can see, not rounded. Ooh, got to be careful. So does it say round to things? Yeah, it's 23.05. So yeah, you can see that rounds to the nearest whole is 23. All right. So what is the measure of the smallest angle in a triangle with the sides 17, 12, 17, and 25? So again, this is an oblique triangle. So we have 12, 17, and 25. So what is the measure of the smallest angle? Well, the measuring of the smallest angle is going to be right there. And again, we're going to have to use the law of cosines, right? So again, we can just write in everything here. That is going to be your angle. So if you're going to solve for this angle, then that is going to be your squared. So it'd be, 12 squared is equal to 17 squared plus 25 squared minus 2 times 17 times 25 times the cosine of theta. Now, my students have a formula to solve for the missing side as well as to solve for the missing angle. But if you guys want to, kind of see, I'm not going to calculate this. I'll calculate my calculator, but it'd be 12 squared minus 17 squared minus 25 squared divided by a negative 2 times 17 times 25 equals the cosine of theta. Okay, so that's basically what I'm calculating in my calculator. Just make sure you're using parentheses when you're typing that into your calculator, use parentheses to plug that in. So I'll do 12 squared minus 17 squared minus 25 squared. And I'd select to calculate that divided by parentheses negative 2 times 17 times 25. End parenthesis. Okay. And then just remember it's cosine of theta equals 0.9058. So therefore theta equals cosine inverse. I don't know why I'm showing this work now. You guys should be able to do this. So cosine inverse of that answer, I get 25. And this is answer 83, which is 25. Boom. All right, so now let's kind of off the trig. Now we're going to get into polar coordinates. So if r cannot equal 0, which of the following polar coordinates polar coordinate pairs represents the same point as the point with polar coordinates? So if you remember when we were dealing with, there's a couple things to remember from this one. R times, kind of think of like one like vectors. R times, well, let's think of this, not R, but think about like the magnitude times the cosine of theta, sine of theta, right? So just remember that a point, R cosine of theta. All right, so a couple things to remember. Remember vectors, and I don't know why I'm not doing the vector problems first because we did cover vectors before polar and whatever. But either way, I didn't have this best organized. Sorry about that. But just to remember, when you're multiplying this vector, like you can have cosine and sine squared, right? That's a coordinate point on the unit circle, right? That represents any point on the unit circle. So V represents your magnitude. Like, does that have a magnitude of 1? Does that have a magnitude 2? Like, that is your magnitude that you just multiply by that, vector, that unit vector, as we say, in our vectors unit. Well, remember, if V is negative, like that's just going to be reflecting, or magnitude is never going to be positive, or magnitude is always positive. But when we have a vector that's negative, that's just going to reflect in the other way, and the magnitude expands that. I'm not really doing a great job explaining this, and I'm not really sure why I need to be explaining everything because we've already explained it, and I'm just kind of going off my end. So I'm just going to eliminate my thing because it's already been too late, going too long. All right. The main important thing we need to remember from this is let's just cut to the chase. So just remember, guys, if you have a point here, right, this same point is equal. It's basically always 2 pi. You can see they're always going to be pi away from each other. So, and the way that, again, the conversion, the way to represent any polar point as a rectangular point, r cosine of theta times r sine of theta. All right? So if you have a negative r, that's basically like a reflection about the origin, is a way to kind of think about that, which is pi away. Now, this one's pi away, but it's for the same r, right? So that doesn't work. This is for a reflection about the origin, like pi away again, but again, it's the same r, so that one doesn't work. This one's for 2 pi, which is going to be the exact same angle. That doesn't work because it's for negative. And this one is the exact same, looks like the exact same angle, just a reflection. The only one that's going to give you the exact same point is when you have a reflection, and then this one is plus 2 pi and then plus pi. So it really is that adding 3 pi is really a reflection about the origin for that negative r. And the interesting thing that you can have is, if r was negative, so here's a coordinate point that on a polar point. If r was negative, you're going to use the same angle. It's just going to be the same angle in a quadrant that is directly reflexive about. And that was something that we talked about in our class, how to find those. So, for instance, I guess I can elaborate here on an example. So, which of the following are the rectangular coordinates of the point with the, this is just rectangular points. Well, I guess I can answer that. So again, if I want to convert these rectangular points, just do -2 times the cosine of -pi/3, comma, -2 times the sine of pi/3. And like literally, that's as easy as it is. We just now need to use the unit circle to figure out what the heck that is. So let's go on where -pi/3 is. That's down here, right? So hopefully you guys know that coordinate point here. That's going to be a -2. The cosine of that is going to be a 1/2. And this would be a -2 times the sine of that, which would be a negative square root of 3/2. So my final point here becomes a -1, and negative times negative, and that would be a positive square root of 3. So I'm getting answer C, which is 84. Sweet. Now, my other point that I was trying to bring to you is, let's look at this point. This point is directly a reflection about the origin. So that's going to have if you wanted to use this angle. Now notice you're going to want to use positive 2 because this angle, this coordinate point, is a negative 1/2 positive square root of 3 over 2. So if you were to multiply this, same thing, 2 cosine of theta, 2 sine of theta, you would get the exact same answer. Notice how these have the exact same answer. Okay, so again, it's r, so it'd be the opposite radius. So this one's negative, then it's r, but then it's a reflection. So whatever angle point is a reflection about, which this angle, which would be adding negative pi half, so that'd be 2 pi over 3. So it'd be like 2 cosine of 2 pi over 3. And then 2 sine of 2 pi over 3. All right, I don't want to get too much over into everything. I know I've already been going on way too late here. All right, let's go ahead and keep on going because we're almost there. We're in the 80s, guys. We're in the 80s for anybody that is still here. That's still watching in. Yeah, I'll try to see. I probably won't get before midnight, but whatever. So next one says, which of the following polar coordinates pairs represents the same point as the point with a polar coordinates 2, 210. So here kind of comes to that same point. So here's what we're exactly dealing with. So let's graph 110 degrees. So add radius 2, right? So 110 degrees is going to be right here. Now again, basically the easiest thing to do to have the same coordinate, these are all negative. So 2 at negative 70 and 2 at 290, those are not the same angle, so those don't work. So if it's going to be a negative, that means it's going to be down here, right? So we got to figure out the point that basically, what is this angle? That's what we need to figure out. So we're going to reflect it about the origin. So what is that angle? Is that negative 70 degrees? Looks about right. It's not 110 degrees. And negative 250, that would give you, go back to here. So that's not going to work. It's going to be answer A, which would be down there. So you got to use that angle that is the reflection. A, negative 270. Perfect. All right, 86. Which of the following polar coordinates does not represent the point with rectangular coordinates negative 2, negative 2? So in this case, we have the rectangular coordinates. We basically want to find the polar coordinates to be able to figure out what exactly is the angle. So remember, for polar points, you basically have the radius and the angle. So the radius is kind of like the magnitude, like it's the length. How far is it away from the origin? So the easy thing to do here is just do negative 2 squared plus negative 2 squared is equal to r squared. And 4 squared is 8 equals r squared. And even though the square root of 8 is 2.828427, or at least an approximation of square root of 8, you can see it's 2 square root of 2. All right. Now you could use positive or negative representation. So we could use positive or negative. I guess I really didn't need to solve that. Now let's go ahead and figure out what the angle is. So the angle, so let's figure out where negative 2 is anyways. Negative 2, negative 2. Let's do this again. This is the important thing actually to understand. Negative 2, negative 2. Right here. Here is your polar point. Now we don't know the radius. Oh, actually we do know the radius. It's 2 square root of 2. The important thing I want you to understand, this coordinate point is in the third quadrant. If it's in the third quadrant, the rectangular coordinates, or sorry, here's the rectangular. We're trying to find the polar points, right? Well, I guess that doesn't really even work either. All right, well, here's the rectangular coordinates. Let's make sure these angles will at least give us to this one. So negative 135, yeah, that works. 225, that works. Negative 300, and, well, actually, if you did 200, 225, that would be over here with that radius. Negative 135. Oh, okay. So we're trying to see which one doesn't work, right? So let's do the positive radiuses first, because those are the easy ones. So 225 degrees, which would be from there to there, right? And a radius. That one works. Let's just figure out the angle. God, I'm like losing my mind. Tangent of theta equals the y coordinate over the x coordinate. So therefore, theta is equal to 45 degrees. But again, guys, notice that the rectangular coordinates is in the third quadrant. So it's really, even though it is 45 degrees, that's the reference angle basically you're dealing with. So therefore, it is going to be 45 degrees plus 180, which gives you 225. Or you can subtract it going in the negative direction, and therefore you can see that angle. So that one angle works as well. Now let's look at the reflection, which is a reflection about the origin. Okay, so therefore we're either dealing with a negative 2 square root of 2 and either a 45 degrees, which works, or a negative 315, which that one works. This one, 135 degrees, is over here, right? So 135 degrees is over here. So that does not even match anything. So that is not your answer. So actually, well, it's not your answer, but that's exactly what you're looking for. So the answer in this case is E. Negative 2 square root of 2, 135. All right, next one, 87. Which of the following points corresponds to t equals negative 1 in the parameterization? So now we're doing parametric equations. X equals t squared minus 4, y equals t plus 1 over t. Well, again, guys, they're just giving us what the value of t is, so just plug it in, right? Remember, that's why we use parametric equations to value the t and the y there. So y is equal to negative 1 plus 1 over negative 1. So therefore, x is equal to negative 3. So that doesn't work, that doesn't work, that doesn't work. And then y is equal to negative 2. So it looks like our answer is A. Which of the following values of t produces the same point as t 2 pi over 3 in the parameterization of 2 cosine of t, y 2 sine of t? Which of the following values of t, oh, okay, tired, produces the same point? Kind of forgot what I was doing here. All right, so let's figure out. If it's going to produce the same point, then basically we're going to want, if here's your parametric equations, so 2 pi over 3 is right over here. Basically, we want to figure out the angle that's going to be the exact, that's going to produce the exact same, like cosine and sine. So therefore, if it's going to produce the same, then in the same quadrant, it needs to be in the second quadrant as well. It needs to be basically a coterminal angle of 2 pi over 3. So pi over 3 is not coterminal. Negative 4 pi over 3 is coterminal. 7 pi over 3, which would be all the way around plus pi over 3, is not coterminal. And negative 5 pi over 3, which is, again, takes you back to the first quadrant, is not coterminal. So 88 is B, is your coterminal angle, which would produce the same points. Because if you plugged in 2 cosine of negative 4 pi over 3 and 2 sine of negative 4 pi over 3, that would be the same as using 2 pi over 3. 89, which of the following describes the graph of the parametric equation? So in this case, we can eliminate the parameter, right? And typically when we're eliminating the parameter, we wanted to plug one equation into the other, and typically we want to solve for y. That's how we understand most equations. Notice how we have a restriction here where t has to be greater than or equal to 0. So first thing, let's solve for t. So I can say, if I add a t, so I can have t equals 1 minus x if I was to solve for it. Now let's go ahead and plug that in. So we have y equals 3 times 1 minus x plus 2. And you can obviously see that this is a line, right? That's going to produce a line. However, the parametric equation is not true for all values. It's only true for values that are at 0 or greater than 0. So remember, a line is true for all real numbers, right? Or like, it's going to be, in a parametric equation, a line would be for, there's no restrictions on t. So it can't be a line because we have this restricted. A line segment is restricted both ways, like it'd be between like negative 2 and 5. So it can't be a line segment. So therefore it has to be array, where array is true for, one end stops and then extends in the other direction. So it's array. And obviously this equation does not produce a parabola or a circle. All right, the next one, a rock is thrown straight up from the ground with its positions above the ground at any time where t is greater than 0, given by x equals 5 and y equals negative 16 squared plus 80t plus 7. At what time will the rock be 91 feet above ground? So there's a couple things you can do. You can do kind of common sense here, or you can also just use graphing technology. So, think about it. Like, if the rock is thrown straight up from ground level, so it's at ground level, so that's at 0, right? Therefore, if whatever it goes up, it has to come back down. So if it's going to reach up to 91, unless it either reaches up 91 like at one point, one interval, like exactly at these one intervals, then that could be the happen. Or if it's going to go past, then it has to come back down, right? So, or it could never reach 91 feet at all. So the one thing we want to look at is we want to know for what time is the y value going to equal 91, right? So 91 equals negative 16 t squared plus 80t plus 7. So then we basically just want to find t or solve for t, so we can basically say y is equal to negative 16 t squared plus 80t plus 7 minus 91. And obviously you can go ahead and combine those to negative 84. But basically just go ahead and type those into your graphing calculator. All right, or you could plug some numbers in. Like you could also just use, some other things like look at like 2 seconds, look at what it's doing at 3 seconds, or not even use the graph or use the table feature and of your graphing calculator. And what you'll see is this graph does definitely go past it very rapidly at that. So it does pass 91 feet in the 2 to 3 seconds, and then it comes back down as well. So it passes at 1.5 as well as at 3.5 seconds. And I'm actually not sure, because actually looking at the answer choice, using common sense, you could look at the equation and say the numbers are big enough that it definitely would pass it. But again, like I wouldn't really say that would be common sense. So I definitely just look at the graph and the table. You could obviously just make your own table and plug in values in for t. Notice how the x value is not changing anything. Like, so a lot of the problems that we did, there's x and y values, but this one is just going straight up and it's going straight down. So there is no change in the x value. So we don't really consider anything with this x distance. It's literally just throwing straight up and throwing down. So we only really care about the y equation. Even though the point of parametric equations is to understand the x and the y distance, and that's why they're helpful. So in this case, understanding it as a parametric is not the most useful, but being able to solve for that is important. All right, now let's get on to vectors, which we did before. We taught before polar and parametric. So 91 says, which of the following is a magnitude of the vector 2, negative 1? So just remember, guys, the magnitude of a vector is 2 squared plus negative 1 squared. So therefore, that's going to be, this is the square. The magnitude is going to be the square root of 2 squared plus negative 1 squared, so that's going to be the square root of 5. And actually, let me check 91, yeah, square root of 5. Forgot about the vector formula. Geez, be careful. Number 92 says, let u be negative 2, 3, and v be 4, negative 1. Which of the following is equal to u minus v? So again, when we're subtracting, we're just basically just subtracting our terms. So negative 2 minus 4. 3 minus a negative 1. And so therefore we get a negative 6, and 3 minus negative 1 is a 4. So therefore that's going to be answer E. 93, which of the following represents a vector v with a magnitude of 3 and direction of 150? So remember, guys, we want to use the magnitude direction form here. So the magnitude of the vector times the cosine of 150 degrees times the sine of 150 degrees. So basically we just have 3 times the cosine of 150 degrees. Now let's figure out what the cosine of 150 degrees is. 150 degrees is in the second quadrant. That's 30 degrees, so that's going to be a negative square root of 3 over 2. 30 degrees. No. Yeah. Why am I not getting that as an answer? Oh, yeah, I did. Okay. And then that would be a 1/2. So it looks like the only answer choice that it could be would be C, which I'm hoping that was the answer I got. It is. All right. Sweet. Number 94 says, which of the following is a unit vector in the direction of -1, 3? So remember, the unit vector is basically a vector divided by its magnitude. All right, so basically we just take the vector -1, I, or just I, negative I plus 3j, and then divide it by its magnitude. So its magnitude of that vector would be the square root of -1 plus 3 squared. So that's 1, that would be square root of 10. And then obviously you can just distribute that. So it would be negative I over the square root of 10 and plus 3j over the square root of 10. And looks like C again. Yes, it is. All right. Sweet. Guys, we are in the fourth quarter. We only got conic sections and the limit. Hopefully we can run through those rather quickly. But I'm going to take a break for any of you guys that are still with me here. It's 11:43 right now as I'm going through this. It's been about, let's see how long I've been going live so far. 3 hours and 25 minutes. Awesome. Cool. So equation limit. Hi, how are you? Grayson just watched. Awesome. Glad. Watched some of your videos. You're very helpful. Addison Grace says the video has been great for college algebra exams. Sweet. I am so sorry, Addison. I missed you. I know I was thinking of all you guys in college that were taking your exams, and I really wish I could have got this. Really wish I could have gotten this out sooner to you guys. I really do apologize. But hopefully for college algebra, precalculus, or whatever else you may still take, you'd say, hey, Ethan, good to see you back, man. My mom house. You are very helpful one day. Is this pre-calc 11? Yeah, I mean, it's pre-calc. Who is the CEO of Google? Okay. Aiden, I'm not sure what you're talking about, why I multiplied out, but I will say I am pretty tired and I might not have done the fastest method possible for each of those. So that's definitely possible. But either way, it's just getting through the problems, whatever I can do. Ethan, senior in calc. Awesome, man. I miss teaching calculus. I wish I was teaching it again this year, but maybe next year. We'll see. We'll kind of see how things go from there. But yeah, this year I was only teaching a pre-calculus, and then next year we'll see. Maybe I'll teach a calculus again or calculus now. I'm not sure, but all right, well, here we go on the final one. And again, for those of you that are joining in on the replay or whatever else, just let you guys know, check the replay and check the description. I will have timestamps for this video once it has been fully uploaded. So therefore you guys can go back through the different sections as I completed them. Also, and from there that also regarding that, you can also download the answers that I will have in a PDF for you guys after I'm finished. So we got 2 more sections left, guys. Julio and Chris, Julian, and I'm a funky gamer, ready to get started. Let's do this. All right. So for the hyperbola, represented by the equation, give the coordinates for the center. So just remember, guys, the h is always with x, k is always with y. So this is really, -1, +4. So -1, +4, answer is A, number 95. Don't really need to do anything much with that. For number 96, it says find the center and the vertices. So it looks like we have to complete the square. Awesome. So let's just group the x's and then group the y's. And then get the 289 to the other side. All right, now let's factor out the common factor of 11. And then in this case, let's factor out the 25. This would be a minus a 10y. All right, and then just remember to complete the square here. So I'm going to take the middle term and 2, so I'm going to divide that by 2. So x squared plus 2 divided by 2, 1. 2 divided by 2 divided by 2 squared is going to be 1, so that'd be 2x plus 1, and then minus 25. Complete the square here, it'd be y squared minus 10y plus 25. However, guys, since we completed the square, whatever you add to the left side, you got to make sure you add to the right side. You didn't really add a 1 here. You added a 1 that's being multiplied by 11. You didn't really add a 25 here. You added a 25 that's being multiplied by another 25, or negative 25, actually. All right, so now we can factor this down. So this gets factored down into an x plus 1 squared minus 25 times a y minus 5 squared equals, now let's go ahead and compute this. So this will be 889 plus 11 plus 25 times negative 25, and I'm getting a 275. All right, so right now I know that the center, and actually we can solve the problem from here. So we know the center is negative 1, 5, right? So those two work. Okay. Now, the reason why I said I can solve this here is, notice, actually, you know what? We should probably, yeah. We don't want to, we could, but let's do one more step. Okay. The next thing is, now we want to write the equation. We want this to equal 1. So we're going to divide by 275. Okay, and 275 here, let's see, I think 275 divided by 11, I think it's 25, yeah. So therefore this is x plus 1 squared over 25. And then minus, this would be y minus 5 squared over 11 equals 1. Okay, so the reason why I'm telling you this, or the reason why I'm saying we don't really need to solve and actually figure out the vertices, because I noticed that the vertices here, the vertices are, the x-coordinate is the same, the y-coordinate is changing. So here, my horizontal transaxis is vertical. Whereas this example, you notice that the y-coordinates are the same, but my x-coordinates are different. So here, I have a horizontal transverse axis. Well, since a hyperbola, remember guys, is a squared, and then this one's b squared, since my a squared is under the x, I'm going to have a horizontal transverse axis, so therefore D is going to be my answer, which is number 96. Oh, did I write the answer? Oh, that's supposed to be, oops. I said negative 1, 5, and I crossed out the ones I wanted. So that's same understanding and thinking, just these are the ones that work because those have the right center, right? You can see the center is the same. Here, these ones are vertical and these ones are horizontal. So that's vertical, that's horizontal. And then so it has to be this one, C. All right, identify the parts of the ellipse. So the center, negative 5, has to be negative 4. Well, those are all the same, thanks. Remember, a squared for an ellipse is now always going to be the larger one. So in this case, this is my a squared and this is my b squared. So if a squared is 625, that means a is equal to 25. If b squared is equal to 400, that means b is equal to 20. So basically, if we want to find our vertices, then remember, first of all, our a squared is under our y, right? So again, that means the x coordinate is going to be the same, but our y coordinate is going to be changing. So notice how these two, the y coordinate is the same, but the x coordinate is changing. So these two do not work, right? Because these two are horizontal. We need vertical, all right? And let's see, it looks like the vertices of these two are the same, so let's go to foci. So remember, foci is going to be a distance of c. So to find the foci, we got to do a squared minus b squared is equal to c squared. So a squared is 625 minus b squared, which is 400, which is going to give me 225. Sorry. So this would be 225 equals c squared. So therefore, c is going to be 15. So again, since this is vertical, I've got to figure out which one is going to be adding up and down 15. So my foci is at -5, -4. So I'm going to be adding and subtracting. So it looks like this one is going to work. Actually, that one's all messed up. Yeah, that one's horizontal again. So I should have, you didn't even need to figure that out. You could have just seen that this one goes back horizontal for the foci. So the answer is A. 98 says determine the equation of the ellipse. No, I don't want to determine the equation. I don't want to complete the square again. I think this is the last one that I have to complete the square. All right, so let's complete the square. Dang it. I think this is my last like semi-difficult one that's like elaborate. So 6x squared, just group the x's, group the y's. And then put the 396 here on the other side. Factor out the common factor, so that's a 36. So therefore, that's going to give me a x squared plus 2x. Factor out a 16. Y squared plus, let's see, that's going to give me 4, 5, why can I not do my math anymore? 530. I should know. I can't, my brain hurts. What am I at? 96. Oh, I got to flip page anyways. 6. Yeah, I thought. Oh, it is 6. Hold on. Oh, no wonder. I was like 96. What am I doing? That's a 96. There we go. Yeah. Okay. I was like, what is happening here? And anyways, yeah, that's a Y. Why don't we just rewrite that? All right, so that's a 96Y. So if I factor out 16, that's going to give me a 6Y. And then equals 396. Cool. All right, so let's complete the square here. So 36. This gives me a x squared plus 2x plus 1 plus a 16 times y squared plus 6y plus 9 equals a 396 plus a 1 that's being multiplied by a 36 and plus a 9 that's being multiplied by a 16. So just remember that when you guys are adding these terms by completing the square, you're taking 2 divided by 2 and then squaring it, which gives you 1. So I added a 1 to the left side. I took 6 divided by 2, squared it, which gives me 9. I added it to the left side. But just remember, you're not really adding a 1. You're adding a 1 that's being multiplied by 36. You're not really adding a 9. You're adding a 9 that's being multiplied by 16. So whatever you added to the left side, you got to add to the right side. Now I can reduce these. So I get 36 to a x plus 1 squared. So those two do not work. Plus a 16 times a y plus 3 squared. And let's see, 9 times 16 plus 36 plus 396 is 576. All right, and then if I divide 576 divided by 36, so this will give me x plus 1 over 16, and then 576 divided by 16 gives me 36. Close. And you can see the answer is C for 98. Sweet. All right, find the center and the radius of the circle. So center is going to be 5 comma negative 6. So it's this one or this one. But just remember the radius, guys. Remember this is equal to r squared. So r squared is equal to 50. So you take the square root here. You get r equals the square root of 50, which can be broken down into 25 times 2, which is 5 radical 2. So A is your answer. Find the standard form of the equation of the ellipse with the following characteristics. The foci is plus or minus 4, 0, and a major axis of 12. So remember, guys, the major axis is 2a is equal to 12. So therefore, a is equal to 6. All right. So if a is under 6, now we're going to have 36. So anything where I don't see an a squared with 36 is not an answer. Okay, so those I can eliminate because I know the equation of an ellipse has to have a squared, right? So a squared is equal to 36. Now the foci is a sieve distance, and you can see that's plus 4 and left 4. We could say c is equal to 4, so c squared is equal to 16. But be careful. You know, we should also notice that, remember, the equation of an ellipse is a squared and b squared. So everything with the c squared doesn't, like anything with a 16 doesn't work. That's why that is your answer, A. However, if you want to figure out what B is, remember it's a squared minus b squared equals c squared. So 36 minus b squared equals 16. B squared ends up equaling 20. And since this is a horizontal ellipse, you guys can see that the a squared is going to be under the x, and that's exactly how that works. Number 10 says find the standard form of the equation of the parabola with the given characteristic and vertex at the origin. Focus -1. So we have a focus at -1. So we know the parabola has to open up towards that, right? So if it opens up or down, then we know that x has to be squared, right? And therefore p has to be a -1. So we know that x has to be squared. So it's not this one, not that one. And we know p has to be a negative. So obviously, remember the equation is, 4p times the y minus k. So therefore, this is the only answer that would make sense. 101 would be A. But I think I wrote down, what did I do there? That's the wrong answer. All right. I wrote down the wrong answer for whatever reason. All right, next one is, and guys, we are almost there. I'm almost getting I kind of missed my time, but that's all right. Getting in, so let's go and see what we can figure out. So number 101, say find the standard form, without completing the square, identify the graph of the equation, 4x squared minus 3x. So if you guys remember what we, one thing, there are some notes that we looked at, and just look at these coefficients. And we know that if one is negative, then we're going to have a hyperbola. Like, think of the equation, how does the equation change for these? And I'm just going to kind of do them. A times b is greater than 0. A times b is equal to 0. A times b is less than 0. And a is equal to b. So a is your coefficient of x squared, and b is your coefficient of y squared. So in this case, we have 4 times -3, which is equal to a -12, which is less than 0. So therefore, it's a hyperbola. Last question for this one. It says, find the vertex, directrix, and focal width of the parabola. And in this one, all right, so yeah, it's kind of weird. Make sure that when you guys are doing a problem like this, that you understand that the equation, the standard form of the equation is x squared equals 4p times y. So to understand p, we got to make sure that it's multiplied to the linear form of your parabola. So therefore, if I simplify this, I get 4p equals y. So x squared is equal to 4 times 10 y. So that means p is equal to 10. All right. Now, obviously, we can also see since x is squared, we know the parabola opens something like this. And that is going to be your focus. So the distance from the vertex to your focus, remember, is 10. So your focus, 0, 10, directrix, y equals -10. And vertex is 0, 0, which we already knew. So therefore, you can see the answer is D. So since my focus is not negative, that's why those would not, that's why these two answers do not work. And then this one's having it left or right, so which doesn't really make sense. All right, so now we'll just go and take one last quick little break, guys, before I finish up. I've been set here 3 hours and 44 minutes so far going live, so almost short of 4 hours. But Nisha, thank you for joining in. And Luke, yes, happy to be able to help. Parsa, you should make some physics videos. Yeah, I don't teach physics, I did for a while do my minor in physics, and I was going to do that, but I enjoyed kind of more of like the pure math rather than like math applications. So that's why physics just didn't really connect as well with me. And so can you go over conic parabola? Sorry, I just have time to kind of go over some of the problems that I'm doing over my study, this sheet. I don't want to kind of go over, I mean, obviously there's a lot of stuff I could go over, and I know many of you guys that are watching have other questions in your group and stuff that you want to cover. I'm just not able to kind of cover those. So that's where I'm just going to have to cover from here. So Nisha, thank you very much. I'm very happy to be able to help you out. Ewan says, I'm in 9th grade and tomorrow's my final for math. Any tips? Well, in my time right now, it's 12 o'clock, so I'm not really sure how much more, what else you could really do. I would just probably say go slow. Try to think of the problems. Don't always jump at the first answer you look at. Try to really make sure you understand the question. Make sure you read through the question. And, if possible, if you don't know how to do the problem or if it's confusing, skip it and come back to it later. And, save that kind of brain power. Coming from somebody that makes a ton of mental mistakes, you want to focus on your brain power on problems you know how to do first, and then work on the problems that are going to be a little bit more difficult for you. All right, let's end up, guys, on the last one here. So last one, now we're on the limits. So it says evaluate limit as x approaches -5 from the right. So this one, you have a graphing calculator, but we should know how to graph this. We know the reciprocal function is looking like this. This is shifted 5 units to the left. 1, 2, 3, 4, 5. And it has a horizontal asymptote at 0. It has a vertical stretch of 2, but it's also being reflected about the x and y axis. So as we're approaching -5 from the right, you guys can see that it's approaching -infinity. For number 105, it says evaluate the limit at -infinity. So basically, you notice that there is no horizontal asymptote here. And so what I basically taught in my class, at least for precalculus, because in calculus we do some simpler techniques. But in my class, I just said, just apply, long division. And just to kind of see what that slant asymptote is. Because once you have the first term of your slant asymptote, you don't really need to do the whole long division. You just need to pretty much figure out what that first term is. So -3x to the 6 divides into -5x to the 7. Well, -3 doesn't really divide into -5, so we can rewrite that as a positive 5/3 and then x. So anyways, the main thing to notice is a negative divides into negative a positive number of times. It really doesn't matter what that number is, but it's positive. And then therefore it goes in there one time. Now, regardless of what the rest of the polynomial is, we know right now that is going to be a line, a positive line, that's going to have n behavior as x goes to -infinity of -infinity. So, that graph as it goes to infinity is going to infinity, as it goes to -infinity is also going to -infinity. 106, the limit as x approaches infinity. In this one, you guys can see that the y coordinate is larger than the the degree in the denominator is larger than the degree in the numerator. So therefore, my horizontal asymptote is at y equals 0. In 107, it says suppose limit as x approaches 5 of f of x equals 4. Which of these statements must be true? So again, we don't really know what f of x is, right? It's just some function. So we know the range contains 4. Well, no, it doesn't have to contain 4. Like, what if the graph looked like that? The limit at still approaches, like you hit 5 and here's 4, right? So it's still from the left and right approaches 4 as it's getting closer and closer to 5. As the x coordinates are getting closer and closer to 5, it's still approaching 4. but the range doesn't contain the value 4. F of 5 is equal to 4. No, it's undefined here. Or even if I put like a number, let's say like 10, let's say I put a dot there. Now the value of f of 5 is 10, not 4. So that doesn't have to be true. And that one doesn't have to be true. And as x approaches 5 from the left, f of x approaches 4. So yes, it has to, like if the limit exists, then it has to approach 4 from the left and from the right. So therefore, this one, number 3, has to be true. All right, number 8, it says find the value k that makes the function continuous. Well, obviously at x equals -1, there is some discontinuity. See, we have looks like we have a hole. So let's go ahead and simplify this. Let's factor that. So that would be x, let's see, minus 4 times x plus 1 all over x times x plus 1. So it can't equal -1 because that obviously makes the denominator equal 0. But when you divide that out, you get x minus 4 divided by x. So you can see there is a hole there. But now we can plug in -1 to see what the value of the function would be. So -1 minus 4 over -1, which equals a -5 over -1, which is equal to 5. So the answer is A5. And then some bonus ones that I did not add for my students that I wanted them to just kind of think about. So this one says evaluate the limit as x approaches -2. Again, we see something we want to combine them. So x minus 2 times x plus 2 all over. Let's see, this would be x plus 2 or x plus 3 times x plus 2. Now you can see that at x equals -2, there is a hole, so that gets divided out, and now you can plug in a -2, so -2 minus 2 all over -2 plus 3. So that's a -4 over 1, which equals -4. That's answer A. And then number 10, it's like, what can I do to simplify this? There's not really much you can do to simplify this, right? However, remember, like, not all of them are undefined at their limit. So just plug it in. Just apply your direct substitution. So this is 0 squared plus 1 all over 0 plus 1 times 2 to the 0. Well, 0 squared is 0, plus 1 is 1. Square root of 1 is just 1. 0 plus 1 is 1. Absolute value of 1 is 1. And then 2 to the 0 power is 1. So 1 times 1 times 1 is 1. So the answer there is B. So there you go, ladies and gentlemen. That is your pre-calculus final exam review. And a couple of tips that I'd like to give all of you guys out there. If you've been watching or if you watched this whole stream 4 hours, congratulations, that's awesome. But it doesn't mean anything as far as how you're going to do in your pre-calculus exam. So you can watch me as much as you want, and I really appreciate for those of you that have continued to follow my videos this year or my older videos. But watching is not going to help you do well on the pre-calc exam. You have to practice the problems. A lot of things I like about my channel, or that I think my channel will be helpful for you guys, is I don't do a lot of long videos like this, 4 hours long. But I did cover a lot of examples. But, go through my older videos that, you have the problem, try the problem, and then go to my, video and check your answer. Or go to the problems that you did on your homework or your tests or your quizzes that your teacher gave you that you have the answers to, and practice. The reason why I gave a review like this is for 2 reasons. One, I wanted to highlight some of the topics that we covered this year. But we didn't cover 110 topics. We covered much, much more. So this is just a way to remind students. The only reason why I'm doing this 108 questions is just to remind them of some of the stuff that we did this year. But this is by no way encompasses everything that we've learned in this class. So I told my students to go back to their quizzes, go back to their homework, go back to their tests. I passed all that back, and I said, go back and look at those questions. Look at your answers. Look at if you got them wrong, why you got them wrong. Even ones you got right or ones you got wrong, practice them again. Because there's one thing is just reviewing the material, like, memorizing the stuff. But the other thing is just, practicing, because when it comes time to the test, you have so many other emotions, you have stress, you have mind blocks that come on. So the more practice that you have prepared for the exam, the better, the easier you're going to be able to overcome little, setbacks that you have on your exam and quiz. So either way, guys, I hope you enjoyed this live stream, and I really appreciate for those of you that made it to the end, even if you skipped all the way from the end. But again, please make sure to check the description for the timestamps of when I have hit each and every chapter, as well as your own downloadable copy of my answers and my final review exam. All right, guys, I hope you have a great day, night, whenever you are watching this video. I am going to sign off. Cheers.